We come to this place for science. We come to paleontologizing streams to laugh, to cry, to show up late and then ask what today's topic is even though it's right there in the title. Because we need that. All of us. That indescribable feeling we get when the surf rock starts, and we learn something we've never known before. Not just entertained but somehow infotained, together. Baffling images on a tiny computer screen. Sound that I can feel.
Dirter. A dirter is one of those things you get at the end of the paper towels, the cardboard thing in the middle, you go dir in it.
Genus names I can mispronounce.
Purdue.
Somehow, extinction feels good in a place like this. Our common ancestors feel like the best part of us. And dinosaurs feel like they're still around. Because here, they are. Paleontologizing streams, we make fossils less dead.
Well, hello everybody, and welcome back to Paleontologizing. So good to see all of you here today. We've got an exciting stream planned, and I'm really glad you could be here for it. We're going to be interviewing Professor Susie Maidment, who is one of the world authorities on ornithischian dinosaurs, about her brand new paper that's proving to be, well, it's really shaking things up in the world of European dinosaur paleontology in particular. So we'll be bringing her on in a little less than half an hour here. A little bit late today. There's so many different things that I had to get together for today's stream and other stuff too. Getting ready for some traveling and some special streams. Oh man, it's a good kind of busy though. Anyway, I'm glad that you're here, everyone. If it's anyone's very first time, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. Hopefully you're aware already that a paleontologist is a scientist who studies fossils, the preserved remains of ancient living things. This can be anything from fossil bacteria to fossil baleen whales, from fossil ferns to fossil frogs, and everything in between. Dinosaurs are just kind of the tip of the iceberg, and most paleontologists don't work on dinosaurs at all, but I happen to. Dinosaurs are what I study, what I publish on in the scientific literature, what I present on at scientific conferences, and what I dig up in the field. We spent 11 weeks in the field last year, 11 weeks in 2025, digging up dinosaurs, collecting data, and live streaming nearly every day, trying to give you a first-hand peek into how paleontology really works. That's what I'm trying to do here in my office, too, in the San Francisco Bay Area. It's good to have you here, everyone, and let me know if you've got any questions. During our interview with Susie today, if you have any questions there, don't hesitate to ask them too. We'll see if we can get to them. This is going to be a pretty chill, casual interview. Should be a lot of fun, and yeah, again, I'm glad you could be here for it. Who have we got here in the chat? Let's see. Golganek, Matt M33, Kodali, Lenina, Isolated. Demhask says hi. Welcome, Demhask. It's a name I haven't seen here before. Welcome to the channel. Chilihead, hello. Rushwing and Sloppy Salamander. Tax Art. And Kaze Kuchin. Mudman and Nelf. Alexander Morrison, hello. Dark Muppeteer. What's Shaken? Fence Sama, hello. Pate B and Wombat Hole. I am Morvash and Carl, Classic Brianna Sings, and DeGrowly Bear. Confused Echidna, I am doing well, I hope you are too. Pigeon Coop, howdy. Android Affections, I hope you're doing well, also it's good to see you here. Kenneth Y, VHS James, Kevin661, how's everybody doing? It is good to have you here. And Dr. Terminator, hello to you. We'll see if we can maybe get to some of those news stories too, Dr. Terminator. But again, we're interviewing Susie Maidment in 25 minutes at this point, give or take. And we've also got Thursday Birds Day today too. How could I forget? It is our final stream of the week, and it's Thursday, so it's Thursday Birds Day. Before I forget, let's do a quick post to Blue Sky. There we go. Screenshot. There we go. And thank you, Reagan Nation, for the gift sub there. Appreciate that very much. Thank you kindly. Good stuff. Look for our lights isn't hooked up to that. Figure that out later. Oh, and we're getting a visit from the landlord here. Hello, sweetie pie. How are you doing? That's really goofy looking. We're gonna do a different screenshot. Oh, wrong button. Oh goodness, sweetie pie, you're in the way. We can't see at all. Come here, hey, come over here. Come over here.
I'm interested in your island. It's got nothing to do with oil. I'm a paleontologist.
Bouquet Crafts, thank you for the follow. Welcome, welcome. It's good to have you. Yeah. There. Let's cover that up, sweetie pie. What are you doing? You're such an exhibitionist, you know? You really are. Hey, this is Chris Wright. How are you doing? It's good to have you here. Sweetie pie, my goodness. What are you doing? The camera's all red today. Oh well, we'll make it work. We'll make it work, huh? That's what we always do. That's the nature of a live broadcast. You roll with the punches. Yeah. And you pay the landlords when they come demanding payment right at the beginning of the broadcast. Goodness, sweetie pie. All right. Okay, let's get you some treats, huh? Shake down in there. What I got for you.
Dinosaurs were the sort of creatures you might think of
Platypus.
as inhabiting another planet, or the kind you dream of in a bad nightmare.
Or a wonderful, pleasant dream. Tommy Platypus, thank you for the 30 months of support. Really appreciate that. It's got to be close to a year. I think you're getting close. Thank you for keeping me here online for that long. And yeah, the fossil featured in that clip is Protoceratops. See that big rostrum there? We're going to be talking about ceratopsian dinosaurs today and what characterizes them and their curious purported absence from Europe until very recently. This is all relevant.
If you're feeling a bit cheated, try blaming the dinosaurs.
Thank you, Dr. Terminator. But yeah. Let's see. Quetzalcoatlus. Is that right, Dr. Terra? Some of the, like, nonsense hybrid creatures from the last, what was it called, Jurassic World Afterbirth or whatever? Those are supposed to be as dark as pterosaurs originally? That would have been so much cooler. Oh well. Was not aware of this. But yeah. And there you go, Monday Moon, yeah. Pterosaurs in general are just cool critters. It's nice to see them get some attention, you know? Anywho, let's redo that screenshot there. Here we go. Let's see if that's any better than this. Much better. See, we can work with that. We'll post that to Blue Sky, and we'll see if we've got time to do Metazoa real quick before we bring Susie on. I'm not totally sure we will. Alright. Let's post this. There we go. We've got a special interview with... Oh, here. Hang on. What is this? Uh-oh. Schmenge, thank you so much for the 5 gift subs there. Really appreciate that. Holy cow. 5 lucky chatters won't have to worry about any ads for the next 30 days. Thank you. 5 times 30. That's 150 ad-free days you've just gifted to some lucky folks in this community. I appreciate that. Schmensch. Good stuff. And Kenneth Y got one. Excellent. All right, that's beautiful. I appreciate it. We're interviewing Professor Susie Maidment. Here we go. Here we go. On today's... Well, let's see. About her new European Ceratopsians paper on today's Twitch stream. And you can join the discussion. Put a line break instead. Twitch.tv/Paleontologizing. There we go. With all sorts of 3D printed and Protoceratopsian. Call them Protoceratopsians nowadays? I'm not sure the... And framed Ceratopsian figures. On the wall behind me. Good enough. Okay, alt text doesn't have to be anything perfect as long as there's no egregious typos and everything. Let's just get this thing posted.
Hold on to your butts.
There we go. Beautiful. And Kenneth Y says, is that hers on the wall? No, actually, the Ajkaceratops I was able to print. I've got the there's that post right there if you'd like to interact with that in any way. This right here, if you're talking about this guy, well, let's go through all of them, shall we? Protoceratops, Andrew's eye, right there, from the late Cretaceous of Mongolia. It was from the next, might even be Maastrichtian. Psittacosaurus right here. I forget the exact species for this one, but that's Psittacosaurus, printed life size. And also, we've got Aquilops right here, printed life size as well. And then there's a Leptoceratops. This one's not a 3D print. This is a plastic model that you could get back in the 90s. I tracked that down on eBay a while ago. It's pretty nifty. Love me some Leptoceratops. And a really good times working at a Leptoceratops site in Montana. A whole bone bed of these animals. Pretty extraordinary. Anyway, for Ajkaceratops, this European putative ceratopsian, I'm pretty well convinced it's a ceratopsian. In Susie's paper, we've got digital files of this critter that have been made available to the public. Jim sent these to me, and was able to print the premaxillae right here. So this is actually going to feature in our discussion today, I bet, and it's pretty important. So this is the end of the beak. This right here, but unlike in other ceratopsids where you've got a separate bone, the rostral bone, with this, something different going on, it appears. if this once was the rostral, it has since fused on to the premaxillae, which is very intriguing. So, let's see if we can ask Susie about that today, because it's pretty cool stuff. Yeah. Kenneth Weiss says fossils are so cool. Indeed they are. Yeah. Here, before we... Do we have time for Metazoa? We've got 14 minutes. You know what? We'll do Metazoa later, if we want to. First, I want to introduce you to this paper real quick, before we get into discussing it. Because even though we talked about this a bit yesterday, but a lot of people here weren't here yesterday. I want to bring them up to speed. Here we go, from phys.org. This is a pretty good one. We've also got one at the NHM website. I saw one on MSN. It's starting to get out there into the media. This is cool. I'm glad this is getting some press. Now, here we go. Here's a reconstruction of Ajkaceratops. Ajka is a town in Hungary. That's where these fossils are from. Ajkaceratops is a dinosaur that was described a number of years ago, I think around 2010. And it was purported to be a ceratopsian, and other people are like, no, it's not a ceratopsian. It's not a member of the horned dinosaur group. It's instead a weird ornithopod, another beaky plant-eating dinosaur. And so it's been controversial since then. But with this new paper, Susie and co. have come to the conclusion that it is indeed a ceratopsian, a member of the horned dinosaur group. And I want to get that term out of the way real quick. When I say horned dinosaur, we're talking about this evolutionary clade of dinosaurs. The same group that includes dinosaurs like Triceratops and those guys, Centrosaurus, Pachyrhinosaurus. Not all horned dinosaurs have horns. We just call them horned dinosaurs. And the same way that whales are hoofed mammals, even though they don't have hoofs anymore. You know what I mean? So when we're using that term, horned dinosaur, think ceratopsian. Don't take the term quite so literally and go, well, it doesn't have horns. Why is it a horned dinosaur? That's what we call this group of dinosaurs. I could just say ceratopsian the whole time, but it's kind of a mouthful, especially when speaking with a lay audience. You could say horned dinosaur, just be apprised that the horned dinosaurs don't necessarily have to have horns. Does that make sense? So yeah. Hornless horned dinosaurs. There you go, Deathsaurus. Yeah. And Dr. Terra says, like North America had the hornless Leptoceratops. There we go. Lepto right here and right here. Give me a second. Let me fix the reflection too. This is before the stream started. There we go. That's better. Anywho. So, the really cool thing about this new paper is that it challenges our current understanding of what's going on in Europe at the end of the Cretaceous period. We're talking about geological time here. We're talking about right near the end of the age of dinosaurs. So, Cretaceous, Jurassic, Triassic. Oops. Dinosaurs first evolved probably around about here, about 240 million years ago, back in the Triassic period. They really take over the Earth at the beginning of the Jurassic and hold on to it through the end of the Cretaceous until that asteroid wipes all of them out, except for a handful of bird species. That paved the way for our evolution as large mammals. But man, was that a bummer for the dinosaurs. Our critter here, Ajkaceratops, is from the late Cretaceous. I'm not sure if it's super well dated. I'm sure we'll get that in the paper. But it's going to be from the Upper Cretaceous period. And at that time, Europe did not look like it does today. We'll be talking about this with Susie a little bit, but it was a series of islands, an archipelago, and a shallow, warm sea. Kind of think about like, almost like Indonesia, where Alfred Russel Wallace was doing his fieldwork, like we were talking about yesterday. When we're talking about Cretaceous Europe. Think about, here we go. Kind of like this. Oh, we've got the Iberian Peninsula right here, Portugal, Spain. There's, what, France and Germany, I think. Here's Great Britain right here.
Surely, one of the most remarkable animals that have ever
Wild Luna.
existed, and certainly one of the most famous, is a dinosaur.
Thank you for the 3 months of support there, Wild Luna. Say I love all the learning I get here. Thank you for your amazing work. Oh, you flatter me. My goodness. Thank you for the kind words. I really appreciate that. What we're doing today is it's one of my favorite things to do on Paleontologizing. Talking with other paleontologists and getting the inside scoop on their work and sharing it with you, you know? It's the whole point of this channel is to bring fossil science to the people in the best way I know how. That's what we're all about. So I hope you enjoyed today's interview and the rest of the stream. It's good stuff. Anyway. Indepthosaurus. Figured people should be used to hornless horned dinosaurs since we know Protoceratops for a century or something. Oh yeah. Protoceratops was first discovered in what, like 1922? Yeah, but not everybody has been paying attention to dinosaur science since 1922. There are people here in this audience. Intelligent, clever, curious, well-read, well-educated people who are maybe not familiar with the concept of a hornless horned
field isn't
dinosaur.
narrow to what we understand. On the contrary, we stretch our understanding to try and take in the universe.
But yeah, and Casey Snorts is excited to get the latest scoop on this new paper. Yeah, it's gonna be fun. I've been looking forward to this. Give you a little bit of background. I noticed this this abstract. In the SVP abstract volume, right when that came out. Like, this is intriguing. Ceratopsian dinosaurs were widespread in Europe in the late Cretaceous. It's a provocative title. So we can pull that up and show you. There's the abstract volume there. Show this now that the meeting has happened and now this paper has been published. Such a big document, it's being a little squirrely. Here we go. There's the title. Ceratopsian dinosaurs were widespread in the Upper Cretaceous of Europe. It's the sort of thing that, a sort of title that as a dinosaur paleontologist, it stops you in your tracks. You go, what? What do you mean Ceratopsian dinosaurs were widespread in the Upper Cretaceous of Europe? The thing is, Europe during the late Cretaceous was, you know, a series of islands. Sea levels rose and fell and land bridges formed and were inundated, and this is just constantly in flux all the time, of course. But as a result, we thought that Europe was really strange and very, very different from the rest of the world. Different from Asia, different from North America. In Asia and North America, you've got lots of hadrosaurs, duck-billed dinosaurs walking around. You've got horned dinosaurs in Asia, and especially in North America. You've got the proper ceratopsids, those derived guys with the big horns and frills and everything. It's long thought that we didn't have that in Europe in the late Cretaceous. Until now. So this new paper is, it's exciting. It's provocative. It's challenging something that a lot of us thought we knew. And as such, this is exciting science. That's why it got into the journal Nature, I suppose, which unfortunately is not open access, but it is the most prestigious journal that we have in paleontology. Sorry, journal Science. Nature is... When we were talking about the discovery of the coelacanth on Fishmas, December 22nd, J.L.B. Smith, who described Latimeria chalumnae, the West Indian Ocean coelacanth, talking about publishing this in the journal Nature of London. Back then, this journal had this reputation. It still does to this day. Here's a link right here, and I think we might even have a link to the paper here. I think Susie was actually kind enough to post a link to where you can get the paper for without a paywall. Oh, hang on. It looks like the link is expired. Maybe too many people clicked it. I think it might have been one of those relatively one and done kind of thing. If you go to your local library, your university library, if you email the authors, they'd be more than happy to send you a copy of the paper. But yeah. And Hamster Rain says, I just joined in. Did I just hear Europe is boring for paleontologists? We'll talk about that a little bit. Europe, when you think of the most exciting places to do dinosaur paleontology, Europe usually is not at the top of the list. But that doesn't mean it's not important. That doesn't mean there aren't really cool discoveries to be made, like riddles to be solved, all that good stuff. Even though Europe is where dinosaur paleontology got its start, we talked about that a little bit with Waterhouse-Hawkins Iguanodon, and the Geological Court at Sydenham Park, and all that good stuff, Crystal Palace Park. Even though Europe is where dinosaur paleontology was born, in many ways the locus of dinosaur paleontology has moved to other parts of the globe. But that doesn't mean that Europe isn't important. We'll talk about that today. I mean, shoot, this new paper is it's a good indication of that. But it is exciting news, Jazzy Cat. I'm glad you're here for it. And Deathsaurus says, that's why paleontology is so cool. I love it when stuff gets turned upside down. It's neat because these are the stories that I think we all cherish about vertebrate paleontology, especially as concerns dinosaurs. When a new discovery makes us rethink a lot of stuff, this seems like one of those instances. It's something people are going to be talking about for a long time, and now you can say that you were here for that, you know? I think that's pretty cool. Yeah, instead of Austerlitz, I think I heard about that. Was that in, was it in Italy? Those early sauropodomorph tracks? Yeah. We didn't cover that live on stream, but I heard about that recently. Alright, let's get our camera arranged here. Get things set up for the interview. Let's see, I know Susie's had a very busy day today. So we'll see if she's ready. Are you ready, chat? No, I'll turn off our lighting effects too, so that doesn't get distracting. Excellent. Excellent. And start. Let's see here. Get that going there. Excellent. And hopefully we don't overtax the resources on our computer. All right. Let's see here. There we go. Hey, Susie, can you hear me?
I can. How's it going, Danny?
It's going well. How are you doing?
I am good, thank you.
Yeah, thank you so much for taking the time to talk with us today. I really appreciate it. I hear you had a busy day today, or I'm presuming based on what you told me yesterday.
Well, yeah, I live 2 hours from work, so it's my fault, isn't it? Because I have to go 2 hours into work, and then I have to go to work, and I have to come 2 hours back again. And I had drinks tonight, but you'll be pleased to hear that in your honor, I did not drink in the pub. So I am stone cold sober, which is unusual at this time of night, but I
You
am.
didn't
So
have
there
to
we
do
go.
that for us, Susie. Shoot.
Well, also it's dry January, so I had another reason as well,
Oh,
right?
okay.
No
That makes
fun, no
sense.
fun in my life right now.
Well, I mean, this new paper is hopefully that's brought about some fun. Were you going out in celebration of the paper tonight, or have you been doing this
uh,
otherwise?
Actually not. No, it was a colleague's leaving drink. So no, it wasn't in celebration. But I'm going to save the celebrations to next time that I see all the team on the paper because it's very much a
Nice.
joint one. So
Okay,
yeah.
excellent. Yeah. Um, let's just dive in, I suppose. Tell us a little bit about yourself, Susie. Who is Dr. Susanna Maidment?
I'm a paleontologist at the Natural History Museum in London. That's pretty much it. So yeah, I've worked at the Natural History Museum since 2017. And yeah, I'm a researcher. So my job is just to do research at the museum.
Nice. It's funny. I was a little confused, I think, about what your role is exactly because you do so many different things. You're working up in Birmingham. What's your title there?
I just have an honorary position there. So they
Honorary
uh,
position.
they
Okay.
uh, they give me an honorary title, which is
Hmm.
where I get the title Prof, which means something slightly different in the UK than it does in the US.
Okay,
But
gotcha.
then I run a field trip for them, or I co-lead a field trip for them once a year for their undergraduate. Third year undergraduates to Utah, which is of course a massive hardship, as you can imagine, because basically, not being actually a member of staff, I just sort of go and bimble about and crack jokes,
Uh-huh.
whilst the other people have to do all the kind of organizing and the admin and stuff like that. So yeah, it's an enormous hardship. And we get to dig up some dinosaurs with Josh Lively. Do you know Josh? He's great. He's out there in Utah and he digs up ankylosaurs. So we go dig up some
Yeah.
ankylosaurs with him.
Well, shoot, that's where we saw you back in September. We had you on
Oh, of
screen
course, yeah,
briefly.
of course. There
Yeah.
we were. There we were with you there. Yeah, yeah.
Some people in the chat, I think, recognize you, and other people say, Hamster Rain says, I already like Susie. So is,
Thanks.
I think I said this in the questions that I sent you that like a big part of what we try and do here on this channel is trying to humanize scientists to a general audience, and you make that so easy, Susie. So I really appreciate it. Um, yeah, tell
Well,
us
I've
a little
already
bit
told you
about.
all about my drinking habits, right? So there you go.
There you
You've
go.
got
Yeah.
most of me.
Um, let's get into your background a little bit. So, like, where did you grow up? How'd you get interested in fossils? How'd you get to where you are right now?
So I'm from the southern UK, which is actually, if it wasn't all covered in trees and houses, we would
Hmm.
have as many dinosaurs here as we do in the Western US. So the
Right.
rocks under me right now are from the Wealden group, which are early Cretaceous in age, and they have some of the first dinosaurs ever found. So actually, Gideon Mantell, who found the teeth that were first, he realised these were the remains of giant reptiles that were extinct, and nobody else had ever, have realized this before. So he found the first dinosaur, if you like. He actually lived in the town that I live in right now. So I'm a sort of historic kind of dinosaurs are in my blood historically, I think I would say. But the yeah, I studied geology as an undergrad, and then so my background's very much the rocks, and I love the rocks still do lots of geology. When I was a kid, I spent lots of time finding ammonites. I went on holiday to what is now one of our World Heritage Sites in the UK. So this is on the Jurassic Coast, where Mary Anning found lots of marine reptiles. So I spent lots of time going on holiday there, found marine reptiles there.
Nice.
And so yeah, that's kind of how I got into it. I guess when I was about 7, my grandpa asked me what I wanted to be when I grew up, and I thought that I'd probably quite like to be a scientist. I think I had in my head that you have a scientist wears a white coat and kind of pours, I don't know, coloured liquids into jars and they explode and stuff. And I thought that sounded quite cool. And he said, well, what sort of scientist do you want to be? And I don't think I knew that there were different sorts of scientists. And so I said that, and he said, well, why don't you be a dinosaur scientist? Because, you like dinosaurs, because I was 7, right? Because everyone likes dinosaurs when they were 7. I had like a dinosaur money box and inflatable stegosaurus or whatever. And so he said, well, why don't you be a dinosaur scientist? So I thought, okay, well, that seems fine. So that's what I did.
All right. Yeah. So let's set the stage here for this paper that the whole dinosaur world is abuzz with right now. Let's talk to the audience a little bit about what Europe was like at this time. Paint a picture for us.
Okay, well, we're working in the late Cretaceous of Central Europe, and actually, throughout most of the Cretaceous period, Europe was an island archipelago. So we're on the margins of a kind of tropical sea, the Tethys, and we've got the continent to the north of us is the Fenno-Scandian Shield, so that's kind of to the north, and then the whole of Europe, sea level is much higher than today, so the whole of Europe is just an island archipelago. And actually, it's a little bit difficult to establish exactly where and when those islands existed. But we have had, and how connected they were to each other as well. But we have had, we have evidence of dinosaurs either in marine deposits throughout the Cretaceous of Europe, and then sometimes in terrestrial deposits as well. And from the Central European Basin, we have quite a lot of terrestrial deposits from this time period.
The analogy that I like to use, I may have actually gotten this from Jim Kirkland, is that it's kind of like modern day Indonesia, this archipelago of islands.
Yeah, that's probably fair. Yeah.
Maybe even a similar climate, maybe a little bit less tropical because it's not as near the equator. But if we're just trying to like get people to imagine this, and then those islands would have been constantly joining up via land bridges, and then the land bridges get inundated. Like this whole place is going to be in flux all the time, right?
Right, exactly, because we've got lots of tectonics going on. We've got the Atlantic opening, we've got things going on with Tethys, but we've also got basins, sea level changes and major eustatic sea level changes happening as well. So yeah, islands are going to be joining up, they're going to be getting bigger and smaller, and actually mapping that is really hard. It's quite difficult to figure out, how long those islands persisted for and where exactly they were.
Was there a lot of volcanism at the time too? Do you find a lot of ashes?
I don't know. So I'm going to put my hands up here, and I have not done this field work. So this field work is not me. So I've not been out and studied these rocks. I'm not aware that there's tons of volcanism. I don't think that we have really exceptional, for example, really exceptionally dated sequences. And I would think that if we have if we did have lots of volcanism, we would have very, very accurately dated sediments, and I don't think we do. So I don't think that there's tons of it, but I might be wrong with that. Yeah.
Okay. Maybe tell us a little bit too about what sorts of dinosaurs are known from this area in this time, and is it easy to work on these critters, or is it difficult?
Yeah, I mean, they're quite enigmatic faunas. They've sort of long been characterized as being as showing island effects. So island effects are kind of things that we see today that occur on islands. So islands do weird things to animals, or animals living in islands do weird things. Depends how you look at it. They often have a kind of different diversity. So islands are biodiversity hotspots today, but they also sometimes the animals on them might be a kind of slightly different makeup than we see on the mainland. So they might be depauperate in certain types of animal. So, for example, I was recently reading about the Mediterranean islands of kind of the much more recent past. So, the Miocene and sort of Pliocene and Pleistocene, and they don't have any predators on them. So, for example, we might be lacking, and then you end up with things that, because they don't have any predators, then you end up with things like flightless birds, for example, because the birds aren't getting eaten by any predators. And sometimes we see there's this idea that animals kind of converged on a sort of common body size that was the sort of medium-sized body niche. So really small things get big, and really big things get small. And it's quite interesting because people have tried to look at whether, or have assumed, I would say, that they've almost gone out and looked for these effects on the European islands, and any sort of weird thing gets attributed to island effects, right? So
Right.
you get
Insular
something
dwarfism
that,
and yeah.
right, exactly.
Yeah.
So you get something that's a bit small, and everyone goes, ah, it's an island dwarf. Or you get something that's, and actually maybe it's just a juvenile. I mean,
Sure.
and
Yeah.
then you get something that's a bit anomalous in terms of, well, we don't have any of these anywhere else, and everyone goes, oh well, it's an endemic fauna because it's on an island. Whereas actually in the
Right.
fossil record, in the Mesozoic, almost all our faunas are endemic. We don't see them they're not very widespread, right?
Right.
So
Yeah.
I think anyway, back to your original question, which is what do the animals on these islands look like? We have a range of kind of ornithischians that we might expect. We've got some ankylosaurs, which are quite typical. We've got some, well, we'll get on to the iguanodontians or not. And we've got some theropods. There's a theropod called Balor, which is has been interpreted as a weird theropod, but it's also been interpreted as a flightless bird.
Yeah.
One of these problems with I think working on this stuff is a lot of it is bone bed material. And again, I have not dug any of this stuff up.
Right.
So my part of this really was in the post digging. So that all of the people who really do the digging here are my colleagues Attila Osi and Zoltan Suzuki, and they are really the people who are on the ground doing field work. And Attila's been doing field work in Hungary and Central European Basin for 15, 20 years, and has field seasons all the time with people out there. So they are the people really finding this stuff. But at least my understanding is that a lot of this material is bone bed material. So it's a little bit difficult. It's all jumbled up. Exactly. Yeah. So it's not the easiest to work with. And a lot of it, the material that we have at the Natural History Museum, we've got a lot of historically collected material from this area that was actually collected by Nopscher, who I'm sure many people will be familiar with. He's one of the most important and influential paleontologists of the early 20th century. And he sold the Natural History Museum his collection. He ran out of money and sold the Natural History Museum his entire fossil collection. So we have all his collection. Yeah. So we have these hadrosaurs called Taumatosaurus from that area, from the Hatzeg Basin, and we have these animals, Salmoxes, which I'm sure we'll talk about, which he collected, some ankylosaurs, a dwarf sauropod. It's allegedly a dwarf sauropod. It's a sauropod, a very small titanosaur called Magyarosaurus, and there's actually a slightly larger one that's recently been named, and I forget the name of that. It was named, I think, last year, but another among his material, people now recognise more than one taxon. So yeah, that sort of stuff.
Yeah. Okay. Is it difficult working in that part of the world just because you don't have as much outcrop? I mean, you mentioned coming out to Utah, where we've just got this wonderland of desert badlands all over the place. What's it like in Europe?
I believe so. I was talking to Steve Brasati, who's one of the authors on the paper, and he's been out there a lot. And he says that actually some of their outcrops, they're basically scrabbling around in stream beds. So they're in streams, and they're literally like that. The outcrop is like the bed of the stream, and everything else is grass. So I think that is an issue for sure. I think it's quite it's difficult to find that exposure because it's lush and forested and yeah.
Yeah, no, that makes a lot of sense. And again, just trying to set the stage for the viewers here that if we're talking about these things being really incomplete and mysterious, there's often a really good reason for that. It's not the easiest place to work, and there's not a whole lot of material. It's not a lot of places to look for this fossil material. So let's dive into the Rhabdodontian quagmire a little bit. What is this group of dinosaurs, and maybe give us a real brief rundown of the history of their study, the Rhabdodontians.
Okay, well, Rhabdodontids are a group of iguanodontian dinosaurs, and they are very early diverging iguanodontians. So they branched off before things like Dryosaurus and Camptosaurus and stuff like that. So they're right at the base, but they're late Cretaceous. And so they've got this very long ghost lineage. So some of their close relatives are things like Camptosaurus, which we know from the Morrison Formation 150 million years ago. So we have this very, very long time period where we've got these very early diverging things, but they're like massive ghost lineage. So that was weird. But they are known, the Rhabdodontids, the Rhabdodon itself is a single partial dentary. I can't remember exactly when it was described, but in fact, it's not even complete. It was it's late 1800s to early 1900s sort of thing. Very, very incomplete. Probably not good enough we probably wouldn't name it today.
Right.
Because it's just too fragmentary.
Let alone make
but
it
then
the namesake for an entire group of animals.
Right. Okay, exactly. But then what's happened is, for reasons that I'm finding a tiny bit, as I've got into rhabdodontids, I'm like, why, what? Who made these decisions?
Right, yeah.
Like, basically anything from the late Cretaceous of Europe that looks like it might be an iguanodontian but isn't a hadrosaur appears to have just been randomly referred to rhabdodon.
Right.
So it's based on a single partial dentary. So really, what we'd be looking for today by today's taxonomic standards is we'd be looking for unique features of that dentary. And then I'd find another dentary and go, oh, has this dentary got the same feature? And if it has, then that would be fine. But, people just refer, I don't know, like vertebrae. There's no overlapping material. You can't refer a vertebra to a taxon based on a dentary, right?
Yep.
So people have kind of done this throughout Europe. And then, and then people have named new ones, but almost all of them are based on incredibly fragmentary material. So there's one that's based on a single partial maxilla. There's one that's based on a single scapula. Obviously Rhabdodon, which is just a total wastebasket taxon, which it has a time period of about 30 million years, and is just a whole no clue what that is. And then we have these two species from Hungary and Romania called Zalmoxes from the Hatzeg Basin that were Nopsiotaxa, called Zalmoxes, Zalmoxes robustus and Zalmoxes scipirorum. And these two are the best known. And in fact, Zalmoxes robustus is the best known. And this is bone bed material collected by Nopsia. The holotype, it was then worked on by Dave Norman and Dave Weishampel in the early noughties. So these are two famous ornithischian dinosaur workers. Dave Norman was my supervisor, actually. And they for reasons that I don't know, they decided to assign the because an option never assigned a holotype. So they decided to assign the holotype. I think they just didn't do it at that time, right? It was just that, we hadn't kind of formulated the rules of
it's like how
taxonomic nomenclature yet.
Didn't have a species name originally. So
right, exactly. And the same with iguanodon. So yeah, exactly. So it's just very early, right? So that they assigned this dentary as the holotype, but actually the dentary is associated with other material, with other skull material. But for reasons that I don't understand, Dave didn't mention that. But we know it because that material is in our collection, as I said. So we can go back through our registers, and actually we have Nopsia's notes, right? And Nopsia's handwriting on the specimens, which says, this is individual A. And when you put all the bones together from this skull, you're like, oh yeah, they all fit together. There's clearly, but then there's Dave just assigned a whole bunch of postcranial material to this skull. It's again not clear how that was done because you've got non-overlapping material. So you've got a dentary, and then they're assigning ilia or femora or whatever. It's all bone bed material. We don't have any we don't know what's what. And then they said, oh, but there's another species. It's Zalmoxes scipirorum, and the holotype of this was an associated postcranial skeleton. Okay, so the holotype of robustus is a skull. The holotype of scipirorum is postcrania.
They're not overlapping at all. Yeah.
Not overlapping at all.
Yeah.
Anyway, so it's a bit of a mess. It's a bit of a mess by today's taxonomic standards, basically. Rhabdodontids are, they're in need of revision, and there have been a number of people. Lots of Europeans are working on this. Attila's group in Hungary, Zoli's group in Romania. My friend and colleague Felix Augustin is working in Tübingen on this sort of stuff. So there's a whole bunch of people who have been kind of trying to chip away at various problems to do with rhabdodontids. So things are gradually becoming clearer, but there's still a lot of mess there. Really.
Sure, and it takes so much work to sort out all those messes that are, from so long ago too. I imagine, like you've got to.
Well, we see it is, and we do see them across. It's not unique to rhabdodontids. There's a lot of historically named dinosaurs are really a mess, and my colleague Paul at the Natural History Museum and I made another famous mess, all a bunch of Nome and dubiums last year, where we got rid of a dinosaur called Nanosaurus from the Morrison Formation, where we just went, this is not a thing. And we just kind of wiped the slate clean and went, none of that. Let's get rid of the whole thing, because it's just a nightmare. So, we periodically we have to kind of go through and sort of wipe the slate clean and sort all this out. But Rhabdodontids, they need a look.
Well, and I think this is really cool too, because so much of that work is so essential, and it's so time consuming, and it can be kind of maddening sometimes. And usually it doesn't make for a really exciting paper. It's not the sort of thing that gets a lot of attention. So it's kind of like you do a lot of work for not very much reward, but you've managed to, come up with a groundbreaking paper sorting out this group to a certain extent. And I think that's really cool. You don't see that very often, I guess. So it's
no. I mean, I think a couple of my colleagues have emailed and said, "Wow, you got an ornithician phylogeny in Nature. How do you do that?" But
exactly,
I think it's this is actually, it is absolutely the sort of fundamental work that underpins paleontology is this sort of taxonomic revision, and going through and looking at stuff that we thought we knew in the light of new data, and that's. It's absolutely critical and fundamental. And I don't know. I mean, I certainly, the work I do, I don't do it to be applauded by the media or it's not it's not for the glory, for sure. It's certainly not for the pay. So I'd like to think that that I mean, I do it because I like it, actually. I think there's nothing more enjoyable than having a good old rummage through a museum collection and finding something cool that you didn't know was there.
Awesome. And so that was kind of, well, let's talk about the team that you had here on this paper. You mentioned that you didn't do a lot of the field work, that Attila was doing a lot of that back in Hungary. Who are the other members of the team, and how do they each contribute areas of their own expertise to this project?
Yeah, so actually, I mean, this project really is Attila's. He's the senior author on the paper, and he found the specimen. So he's been doing field work at this locality called Ajkaceratops. I apologize to any Hungarians listening for butchering your language. Okay, I apologize immediately to you. You can correct me for my pronunciation. They're very well. Thank you. He's been doing field work at this locality for a long time, 15 years or so, and has field crews out all the time. So that's, so he's found the material. He originally named Ajkaceratops back in 2010. He then found in the same bone bed this rhabdodontid called Moclodon verosi, which he named in 2012. So he's been doing this stuff for a really long time. And he and Zoltan Suzuki have been working, who works in Romania, on rhabdodontids, similar rocks, similar animals. So they work together. Their students often work together. And Felix Augustin, who is working with Zoli on for his postdoc. And so they had sort of a team of people who were working on this material that Attila had found, and also some more material that we have that isn't published yet that Zoli had found and Felix was working on. And actually Steve Brissati had been involved in some of the original excavations of this material, of the stuff with Zoli. So he'd come out as I think as a postdoc at the AMNH. Mark Norell was involved with that. Matthias Vermeer, who was a Hungarian paleontologist, Romanian paleontologist, sorry, was who Steve was very good friends with. They spent a lot of time working in the field together. So Steve was involved because of kind of historic fieldwork links. But actually he was a bit of a legend because he ended up running the Bayesian analyses for me. So that was really nice, because I don't do Bayesian analyses. So he did the Bayesian work for me there on the paper as well. So he pulled his weight. And then what happened was they were looking at this thing, and working on it, but they wanted somebody to run their phylogenies. And that's kind of my bag. So they actually came to my friend and colleague Richard Butler at Birmingham, whose PhD was on ornithischian phylogeny, and said, will you run the phylogenies for us? And he had worked with Attila on the original Ajkaceratops paper. And Richard said, actually, I don't really do this stuff anymore. So he's kind of moved on. He doesn't really do ornithischian phylogeny. He said that actually the person he needs to talk to is Susie, because she's the person who does ornithischian phylogeny. So they then got in touch with me and said, well, will you run our phylogenies? So I then, I was just looking at photos of this material and sort of, you know, trying to compare it and score it and stuff like this, and then having kind of meetings with everybody to find out, you know, more about the material and understand, you know, some of its anatomy. Lots and lots of meetings with Felix, with him holding things up to the screen and turning them around like this, and that sort of stuff. Hours and hours spent scoring online with Attila. And then actually Luke Mead, who's the final member of the team, is that your cat? It's your cat.
Well,
Okay.
it's not really my cat. She's one of my landlords here, but yeah, this is Mini Pie. You might see some other ones during this interview.
Oh, nice.
Too.
Okay.
Apologies. Yeah.
So yeah, Luke's the last member of our team, and he came in because he is an absolute CT whiz. So we had CT scans of the skull, and what we wanted to do was I wanted to like make these really nice illustrations where we could kind of separate out the bones and show them. And I said, oh, you know, Luke, will you do the CT work for us, the segmentation? And he was like, yeah, fine. And then he started doing it, and he was like, you know what, I could actually do a really nice retro deformation of this skull, and actually we could try and create what the skull really, you know, looked like. And I think that was absolutely amazing, and I think actually those images really helped get us into nature, to be honest with you. So it really helped. But it also his his retro deformation, actually, as I was looking at it, I was like, you know, there are some features here that I wouldn't have noticed from the very squished material. So the skull that we have is like squished flat, and so it did really help for us to kind of understand some more features of the anatomy. So yeah, I mean, everybody contributed in lots of different ways. But yeah, when Attila sent me the pictures of this material, you know, I was immediately, and you know, there is some other material as well, which, as I say, will be forthcoming.
Oh, really? We've got additional material.
Well,
other specimens?
I can't come.
Okay. Wow.
You'll have to wait, see.
Well,
I'm just going to trail that here.
We didn't hear that. Yeah.
And you know, I was looking at this material, and I was like, you know, this is really unusual. It's a very, very unusual thing. But I was really keen that I didn't want to bias the analysis by making it a thing that I thought. So you know, I started looking at Zalmoxes and which of course great because it's in my basement at work. So I started looking at that, and I was like, there's something. There's something really weird about this material. You know, I'm really, yeah, it's really weird. So yeah, it's interesting.
That's really cool. I do want to emphasize the digital models there. That is so cool that like actually retro deforming them, so unsquishing them in the computer actually helped with the analysis.
Yeah,
that's really cool.
I mean, well, for example, one of the things that we were looking at was Ajkaceratops has this big kind of extra hole in the side of its skull, this fossa. Yeah, exactly. It's fenestra, exactly.
The
big fenestra, which we also
fenestra, was it, or
yeah, something like that. Yeah. I think we call it an accessory antorbital or an accessory fenestra or something like that. But it is a thing that we also see in ceratopsians like Bagaceratops, and I think Zuniceratops has one. Diabloceratops has one. Yeah.
Jim Kirkland called me up on the phone yesterday morning and this morning too, and he was very, very excited to tell me about this. He was just thrilled that made it into the paper, and he was very proud that. You know,
because of Diabloceratops. Yeah.
Exactly. Yeah. And Zuniceratops too.
Yeah. Yeah. Well, anyway, yeah. I mean, actually, the reviewers told us to put Zuniceratops in. So, yeah. Nice. Thanks, reviewers. That was a top tip. But we. So anyway, it has this accessory fenestra, and one of the criticisms previously, so a paper had come out just last year from Lukasz Sapinski and Daniel Madzia, who had written a paper and said that Ajkaceratops probably wasn't a ceratopsian, despite the fact that there were some, you know, clearly convergent things. And what they'd said was that, you know, they picked up a number of kind of differences, and one of the differences they picked up was kind of the bones roofing the top of this fenestra. And they said, well, the bones are different. The bones are different in Bagaceratops, but when Luke retrodeformed the skull, so that cat, he's a problem.
She is, yeah, she's feisty. Mini Pie, hey, we're trying to have a professional interview here, please. Thank you. Sorry, Susie.
So when Luke retrodeformed the skull, we could see that actually maybe those bones weren't different, and maybe, you know, that with that retro deformation there was actually spaces where, you know, maybe the nasals did contact this, and maybe da 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 da, da, you know. So it actually really helped us to say, well, maybe actually, you know, that inference is wrong, and actually we, you know, this anatomy does exist in this animal. So that was
interesting. That reminds me of the premaxillae versus the rostral. That's a really interesting thing about this critter. And here, I should show you this.
Yeah.
Thank you so much for making these available. I was able to 3D print the premaxillae right here. So
oh wow, that's amazing.
Yeah,
okay, cool.
Yeah, I did this overnight, and yeah, it's really interesting in that, you know, like I was telling the chat earlier before our interview, with ceratopsians, generally they've got this, you know, the rostral bone is separate from the premaxillae, so they've got this extra beak bone there, and yet we don't really see that with Ajkaceratops, or maybe we do. I wanted to get your take on that, because I know that was one of the reasons why other authors have questioned the idea of Ajkaceratops actually being a ceratopsian. So
yeah,
what's your take on that?
I mean, I don't know the answer. I'll be honest with you.
It's weird, right?
In the phylogeny, in the phylogeny, we scored it as not having a rostral. And actually, we clarified one of the characters to make it possible for us to score it as not having a rostral. So what I didn't want to do was score it as having a rostral when we
and then have that skew
and
your
then
whole
have.
analysis.
Right, well, and have people say, oh, you're just fixing it, you know. So I don't know whether it's got a rostral or not, but what it does have is it has, as you have just shown, is it has this very rugose, very pitted and downwardly curved beak. Yeah, so it's got this very downwardly curved beak. It's also got you can probably just about see from the thing you're holding up, the sides of the premaxillae are kind of indented in a sort of fossy relative to that knobbly outside bit. Right, exactly that. Yeah. So it looks like a premaxilla. Sorry, it looks like a rostral, but there is no suture between the two. We can't see a suture in the fossil, and also in the CT scans, I specifically asked Luke to look for any evidence of a suture, and he couldn't find one. Now, a thing that was super cool was that in that hook-like bit at the front of the premaxilla, the vasculature of that was infilled with an iron cement, and that meant that in the CT scans it like shone, and so Luke was able to segment out the vasculature and show that this kind of front of the snout is really, really, really well vascularized, and we don't really see anything like that in any other ornithischian. The only thing that we kind of looks a little bit like that is the rostrals of things like Protoceratops, or, you know, fairly, you know, sort of Neoceratopsians basically. So it looks like a rostral. It is not like the premaxilla of other ornithischians, but we can't see any sutures. So I think there's two things that are going on. It either does have a rostral, and it's fused at a very early ontogenetic stage, so it obliterates the suture. And we do know
the other ceratopsids do this usually later in ontogeny, but so that's not
usually later in ontogeny. It's not unheard of. And there are even psittacosaurids in which you have no suture, no visible suture. Not all species, but some apparently. The ontogeny, it doesn't have a rostral, and it just has a very convergent morphology of the beak. And I mean, I guess it's possible, and I'm just totally speculating here, that, you know, maybe if these are ceratopsians, we're right, and that they have this you know, the rostral is a synapomorphy of ceratopsia. All ceratopsians have it. Maybe they just didn't ossify it. So maybe what we've got is this like kind of you know, pitted texture where something would have ossified, but actually, you know, it's like cartilage. So maybe they didn't ossify it. So I don't know what the answer is, but I didn't want to fix the analysis, so I scored it as not having a rostral.
Admirable. Yeah. Very cool. So I want to talk a little bit about, you do erect a new dinosaur taxon in this paper, Pharenceratops.
That's right.
Tell us the story there, because if I try and tell this to Chad, I'm going to butcher it, because it's a little bit complicated. This is our first new dinosaur of 2026, which is exciting. What was the reasoning behind it? Like, why did you? What convinced you that this should be a new name?
Well, as I said earlier, I was talking about Zalmoxes, these two different taxa, Zalmoxes robustus and Zalmoxes shakipororum. And what we have done is taken Shakipororum out of the genus Salmoxes and given it a new generic name. So we've made it Ferenceratops Shakipororum. And Ferens, it was the birth name of Nopsha. So we've named it after Nopsha effectively.
Nice.
But the reasoning is that so we did a whole bunch of different analyses, and in all of them, Ferenceratops Shakipororum comes out as a ceratopsian, whereas with Zalmoxes robustus, sometimes it's an ornithopod still, and sometimes it's a ceratopsian. So because what the results of the analysis would do would be to make the genus Zalmoxes no longer monophyletic. So those two species wouldn't be cystotaxa anymore. So we wanted to make it, I guess we're hedging our bets a bit, because we actually, in all honesty, I'm pretty sure that Zalmoxes robustus is a ceratopsian, but because our analyses didn't show it all the time, we decided to split them up and name Shakipororum as a new genus.
Gotcha. Yeah. So in many ways in this paper, even though it's, very surprising and it's proved to be a little bit controversial, you're kind of taking the more conservative approach with a lot of these things. You're being a lot less, I don't know, you're not going out on a limb as much as you could be with a lot of these things.
We're not making stuff up, Danny. We literally we ran the analyses, and that's what it said. And one of the reviewers actually, he wrote, I don't, you've not really made it clear why you think that in the first draft, why you think that Ferenceratops is a ceratopsian. I was like, because that's where it comes out in phylogeny. It's not about its anatomy; it's where it comes out in phylogeny. The anatomy's weird. What I know is that the anatomy is extremely weird, and that also both cranially and postcranially, iguanodontians and ceratopsians are extremely convergent. And there's a couple of reasons for this. I mean, firstly, they evolved from a common ancestor, so they've got like the same, I guess. Right, exactly. But then they both evolved complex chewing mechanisms in their mouth. So they both evolved dental batteries and mega herbivory independently of each other. And they both evolved quadrupedality independently of each other and large body size. So, there are only a certain number of pathways from the same starting point to achieve the same endpoint. So there's an enormous amount of convergence between these two groups. And it is really, really difficult to tease these apart. And I think that's been mainly the reason why people haven't really recognized some of these rhabdodontids as being ceratopsians in the past. There are some really, really, really obvious features, however, which are present in things like Ferenceratops. They're also present in something that was recently described as the K2 rhabdodontid. It hasn't been given a name. It's an indeterminate rhabdodontid that was described by my colleague Zoli recently, and I think as we go and look, it'll be present in some others, which is some features of the pelvis, which are absolutely clear for and synapomorphic for ceratopsians, but they're just not present in. They're just ornithopods, or it's the other way around actually. Ornithopods have them, ceratopsians don't have them. So it's the feature on the ischium. The obturator process on the ischium is an absolute 100%. All ornithopods have it, and Ferenceratops doesn't have it. And there's really, I mean, it just doesn't. It just has a ceratopsian ilium. That's what it is. Ischium. That's what it is. I mean, like, I don't know. It looks like a ceratopsian ischium. So the hips, when you look at the hips, I mean, in 2012, I think I wrote a paper. I was working on the evolution of quadrupedality in ornithischian dinosaurs, and I looked at Zalmoxes. I looked at all of the ornithischians in the NHM's collections. And I looked at Zalmoxes and I was like, the hips on this animal are super weird and they don't look like any other iguanodontian at this part of the tree. They're very, very strange. In fact, they don't look like any other iguanodontian at all. And do you know what? So I made it, I said, actually, and I have a paper in which I say, Zalmoxes is quadrupedal. And this is a sort of independent evolution of quadrupedality on the line of iguanodontia. So you've got all these bipeds and then you've got Zalmoxes shooting off to be quadrupedal. And then you've got quadrupedality evolving later among sort of, more hadrosauroids. And anyway, obviously now I realized if I'd been thinking properly at that time or knew what I knew now about ceratopsian anatomy, I would have, maybe it would have it's quadrupedal because it's a ceratopsian.
Right. Yeah.
So,
Suddenly
yeah. So
yeah.
I recognized this. I just didn't realize I'd recognized it in 2012.
I was talking about that a little bit before our stream today. How for myself and a lot of the people who are here in the audience, one of our favorite things about vertebrate paleontology is how a new fossil discovery can make us completely rethink an entire group of animals sometimes. And this is one of these examples, and it's so cool that we get to see this happening right now before our eyes. It's exciting stuff. That being said, if there were some crazy discovery that were to be made that makes critters like Ajkaceratops an ornithopod again, let's try to imagine, what would that have to be? What would have to be true in order for this critter to become an ornithopod again?
I mean, I actually think it's plausible.
Yeah.
I don't think it's out of the question. And of course, you know, we're scientists, right? And so
Yeah.
the answer is based on the data that you have available to you at the time. And at the moment, you know, we're running these analyses that are based on the data that we have available to us, and that information is telling us that the best explanation right now, based on this current material, is that it's a ceratopsian. But I'm not going to rule out that we find the postcrania, or we think we have the postcrania right. Mochelodon is a synonym of Ajkaceratops, and so we have a lot of postcrania. But yeah, I mean, I don't know. I mean, I guess what would it have to be? I mean, you know, I don't know.
It's not
I mean,
an easy question, so I'm really putting you on the spot with this, but
it's not an easy question, because actually, for me, the postcrania is really compelling. Actually, I work much more on legs than I've worked on heads, and I think it's interesting. Actually, Felix, I'm sure he won't mind me telling you this, was working on the head, and he was like, I mean, Felix really didn't buy this at all. He was like, not down with this, and he was very skeptical. And then he started working on the postcrania. He was like, oh yeah, okay, 100%. See where you're going. Yeah. So it, you know, I think the postcrania for me is really compelling. I guess, you know, if we find a really nice, complete articulated skull, and it's like absolutely, I don't know, like it's got. We know the teeth. I don't know. I mean, yeah, I don't know. I guess if somebody else runs an analysis and they get a different answer, then I'll be like, okay, well, fair enough, you got a different answer. So if you've based it on observation of the material, and you've scored the material and you get a different answer, then that's obviously the best available explanation of that data set.
Right. Yeah. Okay. Fair. Let's maybe talk about Rhabdodontians again for a minute. I don't want anybody walking away from this stream thinking that, like, oh, all Rhabdodontians have to be ceratopsians now. There's some nuance in there, right? And I want to get into that a little bit.
Yeah, there's a lot of nuance in there, and actually, most people have been incredibly enthusiastic about this. There's been a bit of pushback by someone on Facebook. I'm not on Facebook, so I'm only getting screen grabs sent to me of this. But this person doesn't seem to have actually read the paper, because they seem to think that we're suggesting that literally everything that's ever been called even a rhabdodontomorph is a ceratopsian, and we're absolutely not. There are clearly iguanodontian dinosaurs in late Cretaceous of Europe. We scored a taxon that we call the Aix rhabdodon, because rhabdodon is this complete indeterminate wastebasket thing. But there are two skeletons from France, from Aix-en-Provence, and they were found like right next to each other, and they're articulated skeletons, and they've never been brilliantly described. One of them was described in the 90s, and the other one's never been described, but it's been described in a PhD thesis, so you can get pictures of it online. And which is what we scored them based on. And they are, you know, we find in all of our analyses that comes out as an iguanodontian. It's clearly as an iguanodontian. You look at it, it looks just like Tenontosaurus to me. It's clearly an iguanodontian. So yeah, I mean, we're absolutely not saying that all of the rhabdodontids are ceratopsians. What we are saying is that Mochelodon verosi is a ceratopsian, because it's also the same as Ajkaceratops, and that Zalmoxes, probably Zalmoxes robustus, and definitely Phaeronceratops schiphororum is. And the others we'll have to wait and see until we put them in a phylogeny or we figure out what they are. And some of them, I've got to be honest with you, are almost certainly indeterminate.
Nice.
Because they're based on single partial elements. So
yeah, that makes sense. Getting into a different group of dinosaurs for a minute, do you mind if I ask you about Ajkaceratops, because you were a reviewer on that paper, right? Yeah. So I remember, I think maybe you posted part of your review, made it public. For those in the audience who are maybe not familiar, Ajkaceratops is this really weird ornithischian dinosaur from it's from northern Argentina, is it?
I think so. Yeah.
Yeah. Really bizarre looking animal. It got a lot of attention a few years back because it's just really strange, and it's been interpreted as kind of a basal ankylosaur type thing, so an armored dinosaur. But
a basal
it's so
sauropod,
strange
I think.
looking that. Yeah. I remember you saying that you thought there's a chance it could be a weird South American ceratopsian. What was your thinking there? Because it's so fragmentary that it's difficult to tell. But
Yeah,
yeah,
so I mean, it's really interesting when that paper. So I got that paper to review, and it was in. I think it was had been sent to Scientific Reports, and it was by Facundo Righetti, who I know sort of vaguely. And anyway, I got this paper, and I was like, my mind was blown, and I emailed him straight away and said,
yeah,
you need to pull this and submit it to Nature because this is super cool. And anyway, and
yeah,
also I think you need to rerun your phylogenies.
uh-huh,
But anyway, he said that he ran the phylogenies a bunch of times and he couldn't make it anything but a thyreophorine.
uh-huh,
But they did do a good job on the paper. And when I posted some bits of my review because I couldn't be bothered to write out all my thoughts on it again, to be honest with you. But
fair, yeah, you're busy,
I think I was on a train and I was like, oh, I'm on my phone, I'll just post it. But
yeah,
anyway, it was an overwhelmingly positive review. I think I hope it was constructive. But anyway, and what I wanted to do was highlight totally the bonkersness of this animal. It
yeah,
is so
yeah,
weird. It's a biped.
uh-huh,
It's got armor, but the thing that really got me as I was looking at all the pictures and all the supplementary data that they submitted and everything,
hmm,
um, was like what it doesn't have is any features of armored dinosaurs except for the armor. Right.
right,
It has
yeah,
no, there are a number of synapomorphies of armored dinosaurs, a number of features that we look for to make something an armored dinosaur, and it doesn't have any of them.
right.
And the only thing that it does have that is the armor,
Is the
right?
armor? Yeah,
But
yeah,
body armor has evolved, a bunch of times in archosaurs. It pops up all over the archosaur family
yep,
tree. So the idea
yeah,
that
yeah,
and even in other dinosaurs, right? Titanosaurs
sure,
are supposed to have
yeah,
armor plates. So I don't think it's inconceivable that another sort of dinosaur at some point might have evolved body armor that we don't know about yet.
sure,
Especially
yeah,
from somewhere that is poorly sampled in the fossil record. The thing that made me go, could it be? I don't know whether I said ceratopsian or marginocephalian, but anyway, so
hmm,
marginocephalia is ceratopsia plus pachycephalosauria.
Pachycephalosaurus, yeah,
So
yeah,
when I looked at the teeth, so when I got this paper, I went down to the collection and I just went through. It's a great thing about working where I work in the Natural History Museum because you have all these like reference specimens to hand. So you just go through and like rummage around until you find one,
right,
right?
yeah,
So I went and looked for some pachycephalosaur teeth and like was trying to compare them, and I was comparing, and the teeth are really odd. So the closest teeth that I could come up with was a pachycephalosaur, and then it has this
uh,
very deep
huh,
jaw.
uh-huh,
So it's got this kind of like ventral flange on the jaw, and that is something, and it's got a very short jaw, and that is something that we see in some Neoceratopsians, not in all, but in some.
right.
So I think
Things like
Bagaceratops
Bagaceratops.
again.
Yeah, yeah.
Yeah,
Uh-huh.
these has these very deep jaws, and some of them have slightly different morphology. Some are very curved, and some are
Right.
actually deep.
Uh-huh.
But that very short, very deep dentary, um, made me wonder, and the teeth and the tooth morphology made me wonder if it was some sort of weird ceratopsian. I don't know, but I wouldn't be at all surprised if it's a completely new lineage that we have no record of
Uh-huh.
elsewhere, and it's just
Interesting.
it's something
Yeah.
completely different. So
And I
we
mean
need it. We need
that's
some more material, though. I think.
exactly, yeah. It's almost the
Yeah.
same story with your ceratopsians in Europe where the material is so limited and we're trying to do the best we can with very, very limited material. There's so many cool things still out there to be discovered. Um yeah. It if you had a, $5 million grant to go try and find
Lol.
like the missing piece of the puzzle here that the Rosetta Stone being goofy about this for say European ceratopsids or
Mm.
ceratopsians, um where would you look, you know?
Well, that's an interesting question because uh, I think there's a difference. So sometimes, sampling is an issue, right? And there's a
Yeah,
difference between there not having been enough sampling because we don't have enough money to do the work,
yes,
or
not
there
enough
not being
outcrop.
enough sampling because there's not enough outcrop. And I suspect that with the European ceratopsians, that is the problem. What I
Uh-huh.
really want to do, this is totally geeky and
Hmm.
totally self-indulgent, but I'm probably going to do it anyway, is
Uh-huh.
actually I would take your £5 million grant, and I would really like you to give me a £5,000 grant instead, and just let me go around all of those little museums in France and Spain
Okay.
that have drawers full of material that they claim is Rabdodon, and let me go through all of that and have a good old rummage around and, you know, see what's in all of those, because I think the answer probably, if it's out there, it's probably already been found. And we just need to actually, what we need to do is that what we probably don't need to do is find more crap. What we probably need to do is actually you know, work on what we've got and figure out what that is. And in another, I would say that in a better way, you know, revise what we think we knew in the light of new data.
Gotcha. Okay. That's a really good answer. And I think it kind of highlights the importance of collections. I mean, this is something that I talk about all the time on this channel is, you know, that is the, you know, the beating heart of any museum is its collections. Could you talk maybe a little bit about that and how important the collections have been to this project, especially like being on site at the NHM?
I mean, it's really helpful because it allows us to score all this stuff firsthand. So, you know, I can sit there with the specimen in front of me, and then I'm like, oh, has it got this feature? No, you know, it's critical. It's really helpful. But also, I mean, I think that there is this sort of perception that sometimes that museum collections are like a storage, you know, and people will say, oh, is it in your stores? It's not. they're not stores. It's more like a lab
as well. It's the collections stuff that's been prepped. It's been poured over. It's
exactly.
It's so much more refined than that, you know.
Absolutely. And so I'm trying to kind of encourage everybody to call our collections our lab, because that's what it is, right? We have people who are down there studying every single day, who are down there every day. And, you know, the Natural History Museum has one of the world's most important and diverse Ornithischian dinosaur collections. So we have, you know, from the earliest Ornithischian right the way through to late Cretaceous ones. We've got more thyreophorans than we have than any other museums. We've got a pretty diverse Ornithischian dinosaur collection, and so we have a huge number of visitors. I used to be the curator of the collection. I used to look after the collection and look after collections visitors in my previous role. And I think the last year that I did it fully, we had 300 visitor days to the collection in a year. So that's like one, you know, sometimes I'd have 2 visitors in one day, and that would be 2 days, right? But, you know, it's used that heavily. So there aren't even 300 working days in the year, right? So it incredibly heavily used. And ours is not unique. If you go to any major museum around the world, you'll find that there are people working in the collections all the time. And that doesn't even include us, you know, and our students and the people who come and work with us because they want to work on this collection. And it's just, you know, it's really critical for everything that we need to do.
Awesome. Yeah. Before we wrap up here, I want to ask about how you feel about how the paper's been received so far. You said a lot of people do seem to be really excited about it. Is this what you were expecting? Are you happy with the reception so far?
Yeah, I can't believe it. I thought that we would have a lot more pushback, to be honest with you. So many people have written to me and gone, oh my God, this is cool, without going, you're nuts, which is really nice. So it's really, I'm delighted. I thought that people would be more skeptical. Some people who, I mean, so Eric Bouffeteau wrote to me earlier and said, oh yeah, now you say it, they do kind of look like ceratopsians, don't they? And I was like, thanks, Eric. Oh my God. He's somebody, you know, really senior French paleontologist who's worked on this stuff since before I was born, basically. You know, it's really nice to have that kind of feedback. So I'm delighted. And I think that probably, as I say, that I've only seen one dissenter so far who actually said that our paper was a scam, which I thought was a bit much. But I just would encourage him to read the paper.
Gotcha. Yeah, no, I do really appreciate how you just lay everything out on the paper. You make the specimens available as digital models. You really show your work with it, and that's not always easy to do with a nature paper, given that it's so short generally.
Yeah.
I don't know. I was impressed with it.
Thank you, Danny. I appreciate that. It's kind.
Yeah, I think I told you that at SVP, I was really excited for your talk, and I was sitting next to Karen Poole, who also works on Ornithischian dinosaur phylogeny, and Karen was just losing her mind during this talk. Not in a, I don't believe this is crazy kind of way, but like, oh my God, suddenly all of these things make sense. And it was just kind of a magical moment, you know? That was one of the highlights of the conference for me.
Yeah.
So, yeah, thank you for that, Susie.
Yeah. yeah. So Karen works with Kathy Forster, who again, ornithischian dinosaur worker, has worked a lot on ornithischian
I got to
phylogeny, and
meet
she
her
was my
this year at
PhD
SVP.
examiner.
Really. Oh,
Oh,
she
do you?
was.
Great, yeah,
Oh,
okay.
cool. Yeah.
She was
Yeah.
so she examined my PhD. So she, somebody who I've always had a great deal of respect for and have been a tiny bit scared of. And but she's lovely. She's really nice. But she, I guess scared is the wrong word. But somebody who I would like to have a good opinion of my work.
Yeah,
I
absolutely.
would like her
Yeah.
respect,
You care
basically.
about what she
And
thinks.
I
Absolutely. Her
care about
opinion
what
means a
she
lot to you.
thinks.
Yeah.
Yes, exactly.
Yeah.
And she actually, as I walked off the stage, she was like 3 rows back from the front, and she went. And I bent down, and she went, "I want to talk to you." I was like, "Okay, Kathy, yes." And anyway, she went, "Come and find me at my poster." So anyway, I went and found her. And anyway, she was like, "Oh my God, this is so cool. I've got to tell you about my phylogeny, your phylogeny." And I was like, "Oh, whew." I was, yeah, so that was fun.
That's awesome. Yeah. No, I also want to ask about what are some things about this paper that you don't want to see misrepresented? Because we talk about this a lot on my channel about how oftentimes in popular media, science gets misrepresented either intentionally or unintentionally. What are some things that you were careful to talk about in the press that you've overseen for this? And what are some things you maybe might want to emphasize to the viewers too?
I mean, I think a thing that's really important to me is to emphasize that my role in this was really the analysis,
Gotcha.
and that this that lots of the hard work really and years of hard work were done by Attila. Long before I was ever involved with this, and he's the senior author on the paper, and that I think it's really his work, and I just went like 010101 enter, and it popped up, right? So I really want to emphasize that, and I think that what you said about that we're not changing all we're not saying that all Raptodon. There are definitely iguanodontians in the late Cretaceous of Europe, and there might even be a clade. I don't think so. I think they're probably just a grade, but there might be.
Okay.
So I think we need to get rid of the term Rhabdodontids. But we're not saying that all of these taxa that have previously been described as in this area of the tree are now ceratopsians by any means.
So rhabdodontids would become like hypsilophodontids, where it's just
right, exactly.
It's just a general shape of things, but they're not actually related to one another necessarily.
Right, exactly that. And I think probably I would like to emphasize that. Yeah, I think the importance of taxonomy, and doing taxonomy right, and making sure that we have really good holotypes, and that we're referring material correctly based on synapomorphies or tapomorphies, and we're taking a real kind of strict or tapomorphy based approach to our taxonomy, and that will really help us to to make sure that we're not making mistakes. So yeah, I think that they're probably the things. That's quite niche, isn't it? Sorry about that, but I think that's probably
no, this is great. Yeah, that's why I asked you. And before we wrap up, I want to ask too, would you have any advice for people who are watching right now who maybe want to get more involved in paleontology, either in a professional capacity or they just want to learn more about how paleontology works, they might want to volunteer, stuff like that? What advice could you give to the audience? Yeah.
Well, I think there's lots of different ways to get involved. I think if you sort of want to be an academic paleontologist, it's hard. There's not that many jobs out there, and it's it's a tough thing to do, but you have to stick with it, and you have to publish papers. That's the thing. Don't be a perfectionist. That's bad. I think it's much easier but you can be involved in paleontology in ways that don't involve you being an academic, right? You can be a science communicator, you can be a preparator, you can do all sorts of different things in and around fossils that are sort of fossil paleontology adjacent, that don't involve you being an academic. And I think there's lots of different ways to do that. People, I get tons of emails from people asking me if they can join my field work, which unfortunately usually the answer is no, because I don't have regular kind of field campaigns like people in the States do, because we just simply don't have the funding to do it. But I usually try and put them in touch with people who do have that. So people like Lindsay Zano, Harry Woodruff, and actually Attila, And there's some of the Polish guys actually do digs where people can go out and, you can go as a student
cool.
and you can experience digging and stuff like that. Josh, of course, we already talked about Josh Lively. He will take people like that. So, there's a whole bunch of people who do. So I'm always really happy to, direct people. But you can do that. You can go and get experienced in digging up dinosaurs and other fossils. By asking the right people, and often they're very, very happy to have people along.
We need
just
volunteers.
grunt work. Yeah. So that's nice. I think you can obviously go along to your local museum and see whether they have volunteering positions available. I think there's a whole bunch of kind of online stuff. In the UK, we have stuff for kids. There's an organization for kids called Rock Watch, which is kind of more geology, but very involved with paleontology as well. And there's a whole bunch of kind of more avocational societies. So we have the Geologist Association here in the UK, but I'm sure that there's equivalents as well in the States.
We've got a bunch in different states. Excellent. Yeah, thank you, Susie. So let's go ahead and wrap up. Where can people find more Susie Maidment? Is there anything you'd like to plug? And tell us about your podcast too, actually.
I have a podcast.
Yeah.
Yeah, I'll get shot by Rob, my co-podcast host, if I don't plug it. So we have a very, very geeky niche podcast called The Fossil Files. You can find it wherever you get your podcasts. And we tend to tweet episodes out on Blue Sky. Then it's not called tweet, post episodes out on Blue Sky. But Fossil Files. And what we do in the Fossil Files is we take usually a recently published paper, and we do a kind of journal club on it. We read the paper, we interpret it, we say what we think, have a little chat about it, crack some jokes, that kind of stuff.
Nice.
Sometimes we're funny, sometimes we're boring. You never know what you're going to get. But we're quite short.
Button, I suppose. Yeah. Well, excellent. Thank you so much, Susie. Really appreciate your time. I know it's really late there, so thank you for, staying up late for us and joining us after a long work day and everything else. This has been a lot of fun. I hope you had fun.
Yeah, thanks for having me, Danny. It's great.
Of course. Yeah, cool. Well, we'll see you next time. Thanks again.
Speak to you soon. Bye.
All right. Let's go ahead and that there. Fantastic. Sir Susie Maidment, everybody. What an honor. This is the sort of thing that I have a lot of fun doing, and I hope you enjoyed that as well, chat. Holy cow. If you have any questions, I was not as attentive to chat as I probably should have been. I'm still working on building that skill. So if you have any other questions or anything like that, that was the time. Don't be hesitant with it. But yeah, and Casey, so Susie was one of the reviewers on that paper. This cherished tradition in science, peer review. It's so important to what we do, and often one of those things that doesn't get talked about enough. Peer review is one of those things where we do it out of the goodness of our hearts. It's not like we get paid for it. It could be really time-consuming, but that's what allows us to have good science. We check each other's work, and we provide feedback, and it's cool when we've got like a positive story about peer review. Like, it's neat to be able to talk about that and share it with people as a fun little anecdote. So yeah. Based and Jacobild. There you go, CBS Orch. Appreciate that. But yeah. And she did go out of her way to be here. Absolutely, Death Source. It is 8 hours ahead over there in the UK. Which is, goodness. It's what, 11:04 p.m. there? Holy cow. I'm usually getting pretty tired by the time I get up early though. Anyhow. And thank you, Golganek. I'm glad you enjoyed this. Yeah. And I knew everybody would like Susie. Yeah. I was telling her this after SVP too. Like, really excited to do an interview with you when this paper gets out. Yeah. Glad we could make it work. And yeah. I saw this too. Susie does have her own Wikipedia page as well, if you'd like to read more about her. But, by the way, didn't even get a chance to talk about this. Type in the, reading command? There's a book that just came out recently called Strata by Laura Popik, Stories from Deep Time. And, so this book is all about Earth history and how we're able to figure out what's happened on our planet, how it's formed over billions of years. It's full of not just information about geology, but also the people who study it. Susie is profiled in this book. I haven't actually gotten to that part yet. Just started chapter 9 here. But Susie was telling me about this on the post-SVP field trip, and I'm really enjoying this book so far. If you're looking for a nice introduction to the current understanding of Earth history, as told through the rock record and the people who study it, check out this book. Really good stuff. Strata by Laura Popik. You've got an independent bookseller near where you live. I recommend calling them up and seeing if they can get that. That's what I did. Got this from Books Inc. here in the area. And it's good. Very well written. It's funny because a lot of popular science books, you see them all over the place and they're, I don't know, they get a lot of attention, they get a lot of readership, they sell a lot of copies, and then you're reading through it and you go, well, it's a big deal. Like, this is not very well written. This is not one of those books. The prose here is, it's interesting. It really carries you through. It's elegant without being pretentious. And without talking down to the reader either. The author manages to strike a really nice balance there. And that's not easy to do, you know? So I can wholeheartedly recommend that book to you. Yeah. Well, we've got Thursday Birds Day in a little bit. We've got about 2 hours until we start Thursday Birds Day. What do you say we get into Metazoa? I think it may have just reset. And we'll see what discussions that sparks. The next couple hours are going to be a little bit loosey-goosey here after our interview. So whatever questions you folks happen to have, don't be hesitant with those, like I said. Start our daily animal guessing challenge here. What is it? Oh, we've got an hour until it resets. Well, Lenina. Yeah, you're right. 51 minutes. Fantastic. I thought we already missed today's. Oh, this is good news. There's a mystery animal today. We got to try and figure out what it is using an evolutionary family tree as our guide. Most of you know this, but there's going to be a few new people here in the chat. Let's start it up.
Hold on to your butts.
It works a lot like the game Wordle, if you're familiar with that. I think it's the New York Times word of the day guessing game. Except again, we're using an evolutionary family tree to try and narrow it down. This game is heavily tilted toward mammals, I found. Mammals are overrepresented in the database of different animals in the game. Mammals are presumably also overrepresented among the list of developers of the game. So, fair enough. Made by mammals, of course it's going to feature a lot of mammals. Give me the name of a mammal, preferably a placental mammal, that we can start with, and then we'll go from there. Pepper says Hyrax. I don't know if they'll have a Hyrax. Uncle Don's favorite animal there. Don DeBlue. They do have Hyrax. Hyraxes are a kind of afrothere, so they're closely related to elephants and manatees and aardvarks. So it's a little tricky. Non-fictional placental mammals, Death Stars, Bigfoot. Shane's got badger there. We could do hyrax, but I feel like a badger is a kind of mustelid. That's a more speciose group. That might save us a guess there. Odds are higher that it's going to be a carnivoran, like a mustelid, than an afrothere, like a hyrax. We're going to start with badger. We'll go from there. I was lucky enough to, to see a badger. And posed for the camera. An American badger this past summer. Let's see if I can find that real quick. This is doing field work in Wyoming. I was driving Fisher out to the site, and we'd encounter all kinds of cool mammals. There's Fisher looking out the passenger window of my car. Some wild Mustangs. The horse, not the car. Driving a Prius here. But where's our badger friend? This was kind of magical seeing that badger. There's just this weird thing galumphing across the road in front of us. Like, what is that? So I skidded to a stop. And, this critter, before diving into its burrow, it popped out to say hello, and I'm looking for that photo here. Their badger photo. I know I put it up on iNaturalist. Sorry, Chad, I didn't think it would take nearly this long to find the badger picture. Drat. And let me just find it on iNaturalist real quick. Here we go. Observations. There we go. American badger. What a charismatic animal, you know? This is him looking suspiciously at us from the edge of his burrow as we're just stopped there in the car.
Just ask this scientician. He'll tell you that...
Endangered Spirits, thank you for the follow. Welcome to Paleontologizing. Kenneth says, I've never seen these in the wild. They're not the most common. They're a little furtive. They're a little shy, secretive. But I've seen badgers probably 4 or 5 times out doing fieldwork in Wyoming and Utah and Montana. But yeah, pretty cool critter. The American badger. Taxidea taxus. Let's try badger here.
Hold on to your butts.
And see if that gets us anywhere close to our mystery animal of the day. No, nowhere close. Our critter is a deuterostome. It's not a badger. Let me show you what this means. So, for the benefit of anybody new here, living things on our planet are all related to one another. This is some hard-won knowledge. It's paleontology and biology of modern animals and morphology and genetics and all these other different fields have all given us information. It's allowed us to come to this conclusion that all living things on our planet share a common ancestor. As far as we know, all life on Earth came from a common ancestor about 3.5 billion years ago, give or take. That's why all living things share DNA to varying extents. Now let's jump into badger here. American badger, Taxidea taxus. Yeah, CB Sword says, guess a sea cucumber. Are they deuterostomes? I think they're echinoderms, right? Which, yeah, they would be deuterostomes, huh? American badger. We guessed that, and Metazua says, nope, not a badger. Best I can do for you is deuterostomia. So, let's zoom out to the deuterostomes. There we go. Gene 1 says, I mean, you had a 50-50 chance it was either going to be a badger or it was not. Yeah. I don't know if that's really 50-50, but I hear what you're saying. The deuterostomes are this group of animals. So everything from chordates, vertebrates, like amphibians and birds and stuff, to urchins and their relatives. So echinoderms are part of this group, and I think sea cucumbers are also a member of Echinodermata, right? Let's try sea cucumber as suggested by CB Sorge. They're echinoderms, right? Yeah, bingo. There's our sea cucumbers there. Cucumaria elongata. It sounds made up. I love it. All right, let's try sea cucumber and see if that gets us anywhere closer. I think this could be a really good guess because we know that our critter can't be a vertebrate because we guessed badger, which is a vertebrate. And Metazoa didn't say, oh yeah, vertebrata. No. Chordates, which include the vertebrates. There's the vertebrates there. Metazoa didn't say, oh yeah, one of these. No, it just said Deuterostomia. So, it's got to be a member of this branch here, which includes the sea cucumbers. That is going to be, I think, a good guess. Let's see. Let's see. Holy cow. CB Sorge, you didn't know this in advance, did you? I hope not. We're not trying to... I'm not trying to cheat here. Was that a lucky guess on your part? I hope it was. Please say it was a lucky guess on your part. Ha 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 woo. That's... No, it wasn't a guess, or no, it was a guess? We'll take it, I guess.
One of the most remarkable animals
lucky guess, all right,
that has ever existed.
Okay.
And certainly one of the most famous is a dinosaur.
Thank you for the 3 months of support. MCP, really appreciate your keeping me here online for the past 3 months. Thank you for your support. Yeah. Well, holy cow, that's here, let's post that. 2 guesses. Yeah, very nice. Good. We're bringing down that average. That's not too shabby, you know. 51 plays, 51 wins. Yeah. Average guess is 5.2. Not too shabby, you know. They give you 20 guesses to try and get it. Anyway, CB Sorge. Good guess there. Yeah. I got it in a 3. At first I thought red panda, then starfish. See, Alex Vixen, that's awesome. I love how... This is why I love playing this game on stream. You know? Encouraging people to play this themselves and think about the tree of life like this. You know, what Jacob Gardner calls tree thinking. Realizing that living things on our planet are all related to one another, and you can organize the way that you see the relationships as a tree like this. It's an important kind of mental model to have. Whether you're studying any living things, be it sea cucumbers or raptodontid dinosaurs. If you want to actually understand living things, you have to get into this mindset. This is an essential skill to have. To be able to picture their evolutionary relationships in a branching pattern like this, you know? Like we were talking about yesterday. You know, like old Chucky D, I think. That branching tree of life. Which so many of us as scientists seem to have tattooed on our bodies because it is such an important, such a striking image, you know? It's, I personally know probably 5 different people who happen to have this tattoo. Maybe more. Might be closer to a dozen. But yeah, phylogeny is good to learn. Absolutely, CV Search. And I think this might be a good opportunity to get into that a little bit more.
In 1799, a strange animal skin landed in the hands of biologist George Shaw.
We'll use this as a springboard for discussion here. Or maybe we'll save it for another time, actually. You know, we just got Metazoa in 2 guesses. I was talking about how I really appreciate that several members of this chat here also play Metazoa all the time, and they're well acquainted with tree thinking now. Maybe we don't need to do this right now. I'll share this link with you, because it's an excellent video. But maybe we should get into why dinosaurs right now. Not as a philosophical question, but, you know, the documentary. Which has recently been posted to YouTube for all to see. I haven't had a chance to watch this yet, but I'm sure I know a lot of the people who were featured in this. We're probably going to see some familiar faces in it. Why don't we do that? Why dinosaurs? You saw it in theaters in Seattle. Very cool, Petrodactylus. I did not have an opportunity to see it. But, not yet. I'm going to be watching it for the first time with all of you right now. Let's get into that, and then around 5 o'clock, so a little over an hour and a half from now, we'll get into Thursday Birds Day. You've never heard of this documentary, says Deathsaurus? I think you're going to like it. I've heard good things about it. Should we watch a trailer first? Nah, let's just get into it. I don't have that much time.
I think people love dinosaurs because they are big, they're bizarre, and they're extinct.
I don't think that's all of it, but yeah, that is the classic explainer line. Like, I remember Jack Horner saying that. Big, fierce, and gone. You know? I think Scott was one of Jack's students, so maybe you picked that up from him.
People are definitely fascinated by what they would have looked like, what they would have eaten, how they would have interacted with each other.
Dinosaurs are magical,
Oh boy, old subaqueous swimming Spinosaurus thing.
mystical, amazing creatures.
There were giant animals like dragons that lived before time.
Oh man, I remember the time that I ran into Phil Tippett. I was in high school, and I was hanging out at the Ace Hardware next to University of California, Berkeley. And apparently Phil Tippett used to go there all the time to buy plastic models, because in the basement there, it's just shelf after shelf after shelf, aisles and aisles and aisles of plastic models. Model trains, model airplanes, model submarines, model dinosaurs too. Yeah, so I'm like, hey, excuse me, are you Phil Tippett? He's like, yeah. I'm like, big fan of your work. This guy right here, Phil Tippett, not only did he do stop motion animations like Prehistoric Beast, I'm sure you've seen clips of it before, even if you don't recognize the name, but Phil Tippett was also involved with Star Wars. So I think he got started doing the that like chessboard thing from Star Wars in 1977. Subsequently renamed A New Hope, the chessboard thing. And then he animated the Tauntauns and The Empire Strikes Back, the AT-AT Walkers, all kinds of stuff. So the guy's a living legend. And it'd be cool to talk to him about dinosaurs at some point on this channel. We'll see if that's possible. But yeah, he's also, at least at the time, I don't know if he still is, he was a resident of the San Francisco Bay Area. Yeah.
They walked in many of the same places where we walk today, but at the same time, there's so much.
I'm gonna keep pausing it like this. Here's Andrew Farkey. We talked with Andrew, with Andy at the Alf Museum last September. I was going through there on my way to TwitchCon. Yeah, good stuff.
We don't know about them.
You just start to wonder, if these things existed, what else was alive millions of years ago?
Dinosaurs are just kind of everywhere. They're in kids' toys, murals, tattoos.
My name is Tony Compagna, and I am a dino addict.
Jurassic Park is the iconic.
I know this voice. This is Charles Marshall, right? I hope to set up an interview with him pretty soon, too.
Pop culture version of dinosaurs.
It captured the imagination of the audience in a way that hadn't been done before.
They really changed the public perception of dinosaurs, and that has hugely benefited paleontology.
When I find a dinosaur, it's a pretty incredible feeling. It's a huge adrenaline rush.
This bone right here was laying right on the edge of a cliff. Literally, you can't walk without stepping on eggshells and chunks of eggs.
We have teeth, footprints, claw marks, everything you possibly need that could indicate allosaurs were feeding on some large animal here.
New data and new interpretations give us new ways of seeing.
Yeah, Eleanor Michelle. We saw some of a couple of her talks, and we were talking about the Crystal Palace dinosaurs. Just what? Last week?
Things, better ways of understanding.
Molecular paleontology is a young...
Alita! Holy cow! Yeah, I went to school with Alita at Montana State. Alita Bayul, she and I helped dig up Yoshi's trike together. My first summer in the field, 2011. Alita's great. She's in Beijing now, I think.
Science, but it's really going to take over paleontology.
CT scanning is providing
and Kirsten Formoso. I was hanging out with her at SBP back in November.
us this amazing glimpse into dinosaur fossils that we've never really had before.
Paleontology is always the first science that any kid is.
And hang on a second. We had a question from Starmy. This is the beauty of a live broadcast like this is. We got a good question from Starmy here. Apologies for this being a little disjointed, but I want to talk about this. Starmy says, pardon the intrusion, but I have a question that has more to do with yesterday's stream. How does a group go from hypercarnivory to herbivory in gradual steps? The example I know about is Therizinosaurus, evolving from hypercarnivore theropods. How do the food habits of the first couple of generations of the group that evolved into herbivores look like? Oh, I love this. Here's the thing, is that dinosaurs as a group, we think started off as carnivores, with critters like Eoraptor, Eodromius, Eocursor, a lot of Eos. But the earliest dinosaurs we have seem to generally have this sort of body plan. They're small, two-legged, pointy-toothed little critters. Like this. And when I say small, I mean this is about life size here for a little Eoraptor and those pointy teeth. So Eoraptor here might look like a theropod dinosaur, a two-legged meat eater, but there's been a general consensus that's kind of formed recently that Eoraptor is probably not a theropod, it's probably one of the earliest sauropodomorph dinosaurs. Eoraptor here is one of the earliest members that we have of this group. The sauropods, the long-necked plant-eating dinosaurs. The largest animals to ever walk our planet. Little Eoraptor here is maybe the earliest one we've got thus far. That's from what, like the Carnian stage of the Triassic? So dinosaurs all evolved from common ancestor. That's why they are a clade, an evolutionary group. So from one ancestral species, everybody radiated out from them into this huge diversity of different forms. Everything from your super gigantic sauropods to, you know, little birds. They're all dinosaurs. And so somewhere along the way, you had to get from a little toothy meat eater like this into full-blown herbivores, you know? Things like stegosaurs, ceratopsians, sauropods. We've got good evidence that these animals were herbivorous. It's not really disputed. So how do you get that? What's the intermediate like? For some of these, the transition happens so early on that it's kind of tricky, but I don't know, if we're talking about Eoraptor and sauropodomorphs, you've got things like Ajkaceratops here that very well may have been an omnivore. Ajkaceratops and its other prosauropod comrades, these critters may have eaten both plants and meat. Their teeth are, you can imagine them being used for, you know, for cutting meat and for, you know, processing plants. Even Eoraptor itself actually has been hypothesized to be potentially an omnivore. We even talk about it here on the Wikipedia page. Yeah, thought to have been an omnivore, although its dentition is quite similar to that of Dureolestes, which is considered carnivorous. Anyway, a lot of dinosaurs may have been fairly flexible in their diets. When we say hypercarnivory, that might not be the best term to apply to all dinosaurian meat eaters. Things like tyrannosaurs, it's very difficult to imagine them eating plants, obviously. But something like Eoraptor, it's a lot easier. We were talking about Pachycephalosaurus yesterday, and how the teeth at the front of its jaws look like the teeth of a theropod. It's kind of easier to imagine these animals may have been partly carnivorous. But anyway, I guess my point in talking about dinosaur evolution here and bringing up Eoraptor is that the earliest dinosaurs we think were mostly carnivorous or omnivorous, but some of them switched to obligate herbivory, where they have to eat plants. That's what they're doing. That's what they're being selected for. That's how they make their living. And those earlier transitions, since they seem to happen pretty quickly, maybe kind of tricky to pin that down. But therizinosaurs, like you mentioned in your question there, Starmy, they provide a good example. And I've got a clip there with Jim talking about this, and with Lindsay Zano talking about this. In the, what is it, 2007 documentary, Utah's Dinosaur Graveyard.
A close relative of Falcarius, you can see it has sharp blade-like teeth that would be serrated like a knife. If we look at the teeth of Falcarius, you notice they're smaller, more densely packed.
The most extraordinary group of animals that have ever appeared on this planet. The dinosaurs.
Apriel, thank you for the follow. Welcome to Paleontologizing. It's good to have you here. Yeah. Yeah, so Lindsay's talking about that here. That's not necessarily the clip I was trying to find, though. got one with Jim. It's here, I think. Yeah. So this is one of these dinosaurs that I think is... I wish it would get more attention in popular culture. Falcarius. Because I find it totally fascinating. On a number of different levels. Falcarius here is an early therizinosaur from North America. And there are... It's known from not one, but I think at least 2 different bone beds. So we've got hundreds, if not thousands of individuals that all died in the same place. There's potentially like 1 million bones of this animal if you really want to send crews there and dig them all up. You've got an incredible sample size, which is really rare for dinosaurs. Again, the majority of dinosaurs are known from like 1 skeleton, and it's usually pretty incomplete. With Falcarius, you've got hundreds, maybe thousands of individuals, maybe 1 million bones there potentially. They're all jumbled up, but there's so much potential for cool science to be done on them. So sample size, Falcarius has got that going for it. It also seems to be in the midst of a really interesting evolutionary transition. As an early therizinosaur, this is, like Starman was saying, an animal that seems to be in the process of going from maybe a fast-running meat-eating animal into a slower-moving large herbivore. It's also really interesting in that it's a primitive member of the Therizinosauria, so we can see how like this group of dinosaurs kind of starts off. It's got a lot of cool things going for it.
We're very fortunate in this site. We have so much skeletal material from babies to adults. We have every element of the animal represented except for a few parts of the front of the skull and the front of the jaws. It was an animal that probably reached about 3 feet at the hips, walked on its hind legs, had a particularly long tail.
Really lovely reconstruction here by Rob Gaston.
With large raptorial claws. Basically, even for an animal with 3-foot hip height, this thing could probably palm a basketball with its large hands. An elongated neck and a fairly small, elongate head. Particularly interesting in this is it's got very tiny teeth. This thing has probably over 100 teeth. And these tiny teeth were not what you would expect in a typical meat-eating dinosaur.
What's interesting is that when certain dinosaur groups when they're kind of going in the direction of evolving edentulous beaks, toothless beaks, one of the things that they do sometimes is that they evolve more teeth before they lose the teeth altogether. Which I think is really fascinating. We see this in ornithomimids, too, with things like Pelecanomimus. It's got a ton of teeth in its jaws, having a bunch of really, really small teeth, and it seems like maybe they're evolving more and more smaller and smaller teeth until eventually it's just like beak time. I think that's a really interesting kind of evolutionary strategy, and it's something that we seem to see multiple times. The ancestor of Falcarius probably didn't have as many teeth, and its descendants, if it is like on the direct line to things like Erlikosaurus and Therizinosaurus, they're reducing their number of teeth and they just have a toothless beak in the front at one point. So yeah.
This group of animals is thought to be classically plant-eating animals. This is one that is so primitive it might be in the transition.
Yep.
Falcarius is literally caught in the act of evolving from a predator into a plant eater.
The thing that really struck me about this site and the animal once I saw the teeth and the vertebra was that we had a therizinosaur, an animal that's best known from Asia. Only a couple years earlier, a fellow by the name of Doug Wolf and myself, we described the first therizinosaur ever found in North America.
Yeah,
and that was pretty exciting. We were charged. And then just a couple years later, we stumble onto this animal.
So what's another interesting thing, kind of unrelated, but the whole story about Nothronicus, this animal that Jim helped describe. There we go. This cool critter. The story then, when this animal was first described, is, well, we've got this therizinosaur, which is from a group of dinosaurs that are classically thought to be Asian. Here it is in North America, so it must have walked across the land bridge from Asia. How cool is that? And then, a little bit later, they find Falcarius, which is earlier, more early diverging, more primitive, so to speak, than Nothronicus. And it's also in North America, in Utah. Oh, well, shoot, maybe Therizinosaurs actually evolved in North America. Maybe they're North American originals, and then they migrated into Asia. So it's interesting how that whole story can be turned on its head with the discovery of a new critter like that. Yeah. But anywho, to get back to Starmy's question with Nothronicus here. There's a number of different, like, adaptations that this animal shows that, you know, shows that it seems to be moving in a direction to be an herbivore. So here's Lindsay and Jim talking about that.
From its meat-eating ancestors.
So how do we know that therizinosaurs evolved from raptor-like dinosaurs? When we find an animal that's primitive, like Falcarius, we're able to look at its anatomy and see things that have been retained from its ancestors. For instance, in the case of Falcarius, which represents early therizinosaurs, we're still able to see predatory features like sharp claws. In the case of raptor dinosaurs, folding arms. This is the forelimb of Falcarius. One of the things that's easy to recognize about it is that it basically looks like a raptor dinosaur. It's long, it's elongate, the bones are not thick and robust. The claws are still predatory dinosaur claws. There hasn't been that much change in the forelimb.
Yep.
When we look at the legs of this animal, one of the really significant features we see with Falcarius is the lower leg bones are significantly longer than the upper leg bones.
Yep.
These are features we see in running animals. It's a real character of all the Maniraptorans. Velociraptor, the Oviraptors.
The sharp claws, long forelimbs, and fast running capabilities all trace back to the raptor roots of Falcarius.
All later therizinosaurs that we know of have femurs that are longer than the lower legs.
Yep.
This is a sign of an animal that's moving much more slowly. In addition, this animal still has a pretty typical theropod three-toed foot with 3 functional toes, but the little dew claw here in later therizinosaurs becomes larger and actually becomes a weight-supporting toe once again.
What makes Falcarius unique in the fossil world is that now, for the first time, scientists have a missing link. A step in the evolutionary transformation from a predatory raptor to a plant-eating therizinosaur.
One of the things we know you have to do to build a therizinosaur is to take a velociraptor-like animal and give it a huge gut and shrink its legs down.
So having a larger gut is a characteristic of animals that eat plants, because plants typically are not as nutritious than animals are to eat. And so think about like a panda with its huge gut. It's eating bamboo all day. It's got to have really long intestines with lots of gut bacteria in there to really try and wrench out every last bit of nutrition that it can from these very kind of nutrition-poor materials that it's eating. So plant-eating animals tend to have bigger guts than meat-eating animals.
Add a couple extra toes, and lengthen its neck and shrink its head and give it small leaf-shaped teeth instead of those sharp blade-like teeth like a predatory dinosaur would have. Previously, we had no real information on how this transition was happening. With the discovery of Falcarius, we're able to take an in-depth look, sort of a time slice in evolution, and take a close look at what areas of the skeleton are changing.
When we look,
very cool stuff. Anyway, Starmy, I hope that answers your question. Let me know if there's any particulars that you want clarified or expanded upon. I'd be happy to do that. Yeah. With teeth, I can see how the transition from carnivory to herbivory can happen, but plants are so much harder to digest than meat. So what happens for a species to actively try to snack on things it can hardly digest? Part of that might be that new kinds of plants happen to be evolving at this time that were maybe a little bit more nutritious. So that is one of the questions with Falcarius, is like, why would you get this transition occurring? Why go from meat eater to plant eater? And it might have been there were new opportunities with exciting new plants that are just starting to come out. This critter is from the early Cretaceous period, and that happens to coincide with the rise of the angiosperms, the flowering plants. So today, most of the plant species that you see around you, chances are angiosperms. Everything from palm trees to grasses, fruit trees, oak trees, sagebrush, just about everything. These are angiosperms, flowering plants. Angiosperms did not exist during half of the age of the dinosaurs. They did not exist. These plants that are dominant today, it's something like 90% of plant species are angiosperms. These only show up in the early Cretaceous. All of these guys. These groups did not exist before the early Cretaceous period. And when they show up on the scene, they start to take over. This is the same time when therizinosaurs seem to be making that transition to herbivory. And you get the rise of other groups of plant-eating dinosaurs around this time too. The rise of the angiosperms might also coincide with the rise of iguanodontian dinosaurs, their big diversification. The horned dinosaurs, the ceratopsians, like we've been talking about, their big break seems to coincide with the rise of the angiosperms. So it could be a coincidence, or it could be that these animals are evolving to exploit a new food source. That's kind of the classic story that you hear. It's a difficult one to test, but it makes sense. The timing lines up, you know? So that could be a big part of it. Yeah. So what happens for a species to actively try to snack on things it can hardly digest? Angiosperms do tend to be, in many cases, easier to digest and more nutritious than what we call gymnosperms. So gymnosperms are a, like, non-clade, they're like a grade, so like they're not a real evolutionary group, it's just like things that are not angiosperms, we call them gymnosperms. So these are some of your classic Mesozoic plants. Oh, this is a great little diagram there. Conifers, cycads, ginkgos, and neophytes. These are different kinds of gymnosperms. It's funny in that, like, I remember one time years ago, I was hanging out with some paleobotanists, fossil plant scientists. And I brought up a question to the group. I said, are there any gymnosperms that people eat? Most of the plants that we eat are angiosperms. Fruits from fruit trees, even like, you know, people who would eat acorns, like the indigenous people of California would eat acorns. Those are from oaks. That's a flowering plant. You know, grains, wheat, barley, oats. These are also flowering plants, angiosperms. There's very, very, very few gymnosperms that we eat, non-flowering plants. The one answer that I got was pine nuts. Pine nuts come from conifer trees. That's like the one solid example of a gymnosperm plant that we often eat as human beings. There are some people around the world who will eat cycads. They'll eat their fruit or other parts of them, but those are toxic. So you have to, like, leach out the toxins somehow. It's a very laborious process. If you've got other sources of food, you typically don't do that. So anyway, pine nuts are like the one thing. Every other plant that we eat, pretty much, is an angiosperm. I think even kelp, a lot of like seaweed stuff, seaweed snacks. I think that's also a flowering plant. So yeah. So anyway, the point is, the gymnosperms, now this is what dinosaurs were eating for half of the Mesozoic, essentially. And then you get the rise of angiosperms, and it suddenly maybe becomes easier to be a plant eater. Because you get the flowering plants evolving, and they're probably more nutritious in a lot of cases. that might be why we have these different groups of theropod dinosaurs that seem to be evolving herbivory in the early to middle Cretaceous. You get your therizinosaurs, you get your ornithomimosaurs, you get your oviraptorosaurs. These guys all seem to be exploiting a new food source, angiosperms, potentially. They're going herbivorous. They went vegetarian at this point. It might have to do with the rise of the angiosperm plants. So I hope that makes sense, Starmie. Yeah. But yeah, and how many animals eat pine needles? Not very many, Starmie, but we do know that some dinosaurs were certainly doing that. We've got conifer material in the guts of duckbill dinosaurs from the Cretaceous. Whether or not they ate that on the regular, or whether it was extenuating circumstances that made them eat that and then they died, it's hard to say. But we know that they died shortly after eating some pine needles and stuff. Conifer, at least, conifer material. And then we've got good evidence that some sauropod dinosaurs were also eating things like Araucaria. Yeah. But yeah, for the most part, there's not a lot of plant-eating animals that are eating, for instance, pine needles, you know? But yeah. And you're welcome, Stormy. Thank you for the questions. Good stuff. Yeah. And so seaweed described as technically not really a plant. It depends what seaweed is not really like a thing. You get... There's kelp, which is like a photosynthetic protist or something. A lot of things we call kelp are like that. But then you get things like eelgrass, which often gets called seaweed, and that is a plant. It's a kind of angiosperm. So your sea grasses, I think, are straight up grasses. So they're part of the angiosperm group. Yeah, and then you get other kinds of things that are... I think all of the things you could describe as seaweed that actually are plants are angiosperms, flowering plants. But yeah. And modern birds love conifer seeds too. That's true, Neverwinter, yeah. Pine siskins, I think that's where they get their name. Yeah. Anyway, and Caden says, your birds, it seems like, but that's because they're all raptor evolved. Yeah, so all birds are evolved. They evolved from Maniraptoran dinosaurs, which in this documentary that we were looking at here with Jim and Don and Lindsay, so yeah, she uses the term raptor.
A step in the evolutionary transformation from a predatory raptor to a plant-eating therizinosaur.
One of the things we know you have to do to build a therizinosaur is to take a velociraptor-like animal and give it a huge gut and shrink its legs down.
When they use the term raptor here, I take that as they're saying Maniraptoran dinosaur. So this is an evolutionary group of meat-eating dinosaurs. This is the group that birds come from. So, Maniraptoriformes, and there's Maniraptora right there. So the Maniraptorans, this includes the, well, in this tree it includes the Alvarezsaurs, interesting. Plus therizinosaurs, oviraptorosaurs, troodontids, chromiasaurs, and birds. Yeah, oftentimes when... This is why we like to use proper clade names when we're talking about living things. As you say a raptor, what does that mean? If a member of the general public says raptor, they probably mean velociraptor. And by velociraptor, they probably actually mean Deinonychus, like from Jurassic Park and Jurassic World. But in the context of that documentary we were just looking at, raptor, I think they're referring to Maniraptoran dinosaurs. So this entire group that includes the oviraptorosaurs and the troodontids and therizinosaurs. I've also heard the word raptor just refer to theropod dinosaurs. We're seeing Bob Bacher use the term raptor to refer to allosaurs and I think megalosaurs like Torvosaurus in a documentary at one point. I don't know. Raptor. And then, of course, the true meaning of the word raptor, as any birder will tell you, is, well, it's not really a monophyletic group. But its birds of prey are raptors. And I would actually be interested to talk to, like, some of the birders here in the chat to ask if raptor, meaning a bird of prey, still includes falcons. Because we now understand that falcons are not close relatives of hawks and eagles and vultures and owls. Falcons are their own thing. They're way over by the parrots. So is a falcon, like a peregrine falcon, for instance, still a raptor? Because if it is, then... oh, shoot. That would be an example of, like we were talking about yesterday, the day before. Folk taxonomy. So this is like the names that people come up for living things that it's not really based on their evolutionary relationships or what a thing actually is. It's like, it's just based on vibes, you know? Yeah. Like bugs, you know? Or algae, or vegetables, or shrubs, you know? Shrubs is not a real botanical term. It's not like a group of plants that all share a common ancestor. It's just, it's a plant, it's not that tall, it's a shrub, you know? So yeah. Anywho. Claire Burr says, when did we start calling birds of prey raptors? That's a good question. Long time ago. So here's something that I think a lot of folks kind of forget. The word raptor in reference to non-bird dinosaurs, that started with Michael Crichton. That's because of the novel Jurassic Park and the subsequent movie. Nobody called non-avian dinosaurs raptors before that. That comes straight from that book. And we've talked about this before, but it's kind of a funny story how Deinonychus gets called Velociraptor in the Jurassic Park novel, and then in the movie, and then... yeah, that's how that name was really introduced to the public. Before Jurassic Park, Velociraptor was a fairly obscure dinosaur. It was described by Henry Fairfield Osborn way back in 1924. He named, I think, 2 other theropod dinosaurs in that same paper. It wasn't a big deal, not a lot of fanfare. Only, like, your true dinosaur nerds knew what Velociraptor was until Jurassic Park came out, and then suddenly everybody knew about this animal afterward. So yeah, it's interesting. Yeah. And raptor isn't a clade, it's a calling, says Handed Pendant. There you go. Yeah. But yeah. Anyhow, and Le Petit Prince Encore says they grab the prey, and usually it's still alive when they feed it to their young. Yeah, so raptorial is a term that we have too, like raptorial forelimbs. You even hear that applied to things like anomalocarids from the Burgess Shale and their Cambrian assemblages like this. So these appendages on the front of the animal, these are sometimes called raptorial appendages. It's just an adjective that means, like, grabby, you know? Grab ya. So yeah. No, and mantis shrimp. There you go, Alexander Morrison. Yeah, I've heard that applied to them too. Yeah. Anyway. Yeah. Good stuff. Anyhow, we had another question, didn't we? That where was that? Raptor Advanced Jet Fighter. There you go, leopard prints, yeah. But yeah, anyway. Yeah, depending on how you use the term raptor, it could have referred to a particular genus of dinosaur. Or Dromaeosauridae, the family the Velociraptor belongs to. Or it could be Maniraptoran dinosaurs, which also include birds. Or it could just be a particular group of birds, the Acipteriformes. They're relatively. Or it could be a paraphyletic group of birds. Anyway. Yeah. But yeah, I tried to steal my glasses again. There you go, chaotic time travel. But yeah, the word raptor does mean thief. And let me show you the original paper that Osborne published back in 24. First, describing Velociraptor. We talked about this, what was it? Not this past November, but the November before. The 100th anniversary of the publication of Velociraptor. I think it was November 7th this was published. 24, there we go. For Windows search to pull this up. There we go. Yeah, the AMNH Novitatis. This is the in-house journal for the American Museum of Natural History in New York. Come on now. There we are. Yeah. So it was in this humble paper here that Henry Fairfield Osborne, the same guy who named Tyrannosaurus Rex, actually. He really had a knack for naming things. Osborne may have been kind of a tedious guy, real racist jerk, maybe a third-rate scientist in many ways, but man, he came up with some good names, and he was very good at fundraising for the museum, and he helped build the paleontology program. Yeah, Osborne. Yeah, 3 new theropoda for the Protoceratops zone in central Mongolia. Yeah, the first of the typical megalosaurian type. These old favorites. Although of small size, seems to have been alert, swift-moving carnivorous dinosaur to which the generic name Velociraptor is applied. Velociraptor mongoliensis. I don't even know if he talks about what the name is supposed to mean, but it means like fast robber, swift thief, speedy Caesar. However you want to translate that from Latin or Greek or Latinized Greek or whatever it is. But anyway, it's funny that like Velociraptor is given the same attention as Saurornithoides in this paper. And how many people in this chat had ever heard of Saurornithoides before? You know? How many of you have ever in your lives heard of this dinosaur, Saurornithoides? Probably not too many. Kevin says me. Yeah. Well, some of you have. Yeah. Yeah. Little Troodontid. Published in the same paper as Velociraptor in 1924. Saurornithoides. There we go. It's based on some good material, but yeah. A big part of why this dinosaur is not as well known, frankly, is the name, you know? It doesn't roll off the tongue in the same way that Velociraptor does. Yeah. And Saurornitho, does it refer to flight? That means the lizard bird form, Saurornithoides. Ornithoides. There we go. Yeah, which, bird-like theropod. That's not what the name means. It means soar, lizard, ornitho, which means bird, and oides is form, the lizard bird form. Yeah. It's funny, because, like, Osborn recognized that a bunch of these different dinosaurs, Velociraptor, Sauronithoides, Oviraptor, all very bird-like. He kind of just goes, huh, that's weird. The idea doesn't really sink in. Like, he doesn't really run with that. That this is an animal that's very bird-like and probably very closely related to birds. I don't think Osborn ever really sticks his neck out and says, yeah, shoot, I think birds might be a kind of theropod. I don't think he ever does that. It seems so obvious in hindsight. You know, maybe it's that this was a... I'm just realizing this now, but Henry Fairfield Osborn was a Cope acolyte. Osborn here he was on Team Cope. Let me explain what I mean for those of you who are... This is not like Twitch lingo. This is not internet slang. Marsh and Cope were two rival paleontologists toward the end of the 19th century. There's Marsh with the big bushy beard, the bald head. Cope has got the mustache there. These two guys had a fierce rivalry that took them all across the American West, each trying to find the most and the best fossils and just sniping at each other in scientific publications and also in the popular press too. It's a whole thing. This is like the most famous wide-ranging rivalry in dinosaur paleontology. It's the stuff of legends. To this day, most of us in dinosaur paleontology and vertebrate paleontology in general, in the US and also throughout other parts of the world, we can trace our ancestries back to either Marsh or Cope. Like, oh yeah, my doctoral advisor was a student of this person who was a student of that person who was, you go back far enough and they're a student of Marsh or Cope. Sometimes you have both. Depending on how you map out my academic pedigree, I'm a descendant of both Marsh and Cope, sort of, if you squint. Anyway, the point is, Osborn here. Osborn was a descendant of Cope. Marsh had become convinced that birds evolved from theropod dinosaurs. And since this was a Marsh idea, maybe Osborn, as part of Team Cope, was really hesitant to run with that idea. He's like, oh boy, that's some Marsh stuff there. I don't know. I wonder if that's part of why Osborn never seems to really run with this idea that these super bird-like dinosaurs, once he recognized as being bird-like, like Sauronithoides, and Oviraptor, and Velociraptor, and all three of these guys, maybe that's why he never runs with that idea. It's an interesting thought, you know? Yeah. I want to run that by some of my colleagues and see what they think. We're at war, Danny. Pick a side, says Diatoms Attack. Diatoms, have you seen the... Have I asked you about this before? The academic family tree? Are you familiar with this Diatoms Attack? By the way, if anybody here is not yet following Diatoms Attack, you're missing out. He does really cool science outreach streams here on Twitch, looking at diatoms, these incredible microscopic photosynthetic organisms that produce a lot of oxygen and a lot of good data for ecology, for biostratigraphy, for all kinds of... Diatoms are so important. If you want to learn about them, go follow Diatoms Attack. But are you familiar with this right here? academictree.org? This is such a fun little project. Well, little. I don't mean to
disparage it or downplay it. But here, evolutionary biology. There we go. Search a person or institution. Here, let's do Jack Horner. Security check. All right. There we go. I love this. And so, oh man, so many of my friends and colleagues are on here too. This is wonderful. Lee Hall, LJ Krumenacker, Ash Paust, Josh Bondi, Jade Simon, Danny Barta, Chris Organ, Jacob Gardner, my old roommate, is on here. Anyway, so these are descendants of Jack Horner. He was either their advisor or the advisor of their advisor. Here's my undergrad advisor here, Dave Verricchio. So I could trace my own academic ancestry through my undergrad advisor, through Jack Horner, Donald Baird at Harvard, Al Romer at Harvard, William King Gregory, Henry Fairfield Osborn. And Osborn here goes back to... Well, shoot, Cope was never his official advisor, because Cope wasn't really like a professor. But anyway, he was a Cope guy for sure. But yeah, it's pretty neat. Depending on like which way you go in my academic pedigree, you can get to either Marsh or to Cope. Yeah, and for a lot of us, we can trace it directly back to old Chucky D, Charles Darwin. Kind of at the very beginnings of biology. It's cool stuff, you know? Can you trace your lineage back to Carl Linnaeus? I don't think so, Mayor Space, because Linnaeus... I don't know. Sometimes it gets a little tricky when you, like, hop across the Atlantic. So we can see if we... Here. Let's try this with today's interviewee, Susie Maidment. There we go. Here's Susie here on the evolutionary biology academic family tree. And I guess this doesn't go back as far. It's not always super complete. But yeah, Dave Norman, like she was talking about, her PhD advisor, to Barry Cox at King's College, Francis Rex Parrington, and Clive Forrester Cooper. I'm not super familiar with that name. But yeah. This might also be, it might be kind of US-centric. People had to put this information into this system in order to, to build this site. And so, not all of these are going to be super complete, you know? And Hey Keith says, trace it back far enough, you can single out the entity who gave rise to the entire field of science. The last universal scientific ancestor, is that what you're saying? Lusa? I wonder how far back it goes, actually. If you would put, like, Aristotle in here, do you think that would yield anything? No, probably not. But you could try somebody like Lamarck, Jean-Baptiste de Lamarck. There we go. Or maybe Cuvier. But yeah, there we go. Jean-Baptiste de Lamarck. Three main descendants that are listed here. One of them, Robert Edmund Grant, who is the academic ancestor of Charles Robert Darwin, Chucky D himself. Huxley, one of his students. And Huxley was an early proponent of the idea that birds evolved from dinosaurs. And there we go, Henry Fairfield Osborn, right there. You could call him a descendant of Thomas Henry Huxley. And it was from, we can try and trace it down now from Osborn. Let's try and get to like Jack Horner. Gregory, Edwin H. Colbert, John Ostrom. Oh, Kevin Padian. This is so cool. We just traced it back from Charles Darwin to Kevin Padian, who might want to interview on this channel at some point. Randy Ermis, Matt Wadle. We were just talking about him the other day. John Hutchinson. Yeah, Jacques Gauthier, Sterling Nesbitt. This is so cool. Andy Heckert. I know so many of these people. Sarah Wording. I was at Berkeley at the same time she was. Yeah. Anyway, yeah. I find this stuff charming and amusing, and I get into this. I hope it's not too in the weeds or too, I don't know. Yeah. But yeah. Yeah. And Ibn Sina, I don't think we go back that far, Cacklinsworth. Yeah. But yeah. Anyhow. And Chozo Ninpo, how are you doing? Welcome to Paleontologizing. Howdy, howdy. And Hanaconda Aquaponics. Chucky D didn't like their city where their university was. Can't wait to leave this godforsaken place. Where was that, Hanaconda, if you don't mind me asking? And none of the famous academics I looked up around there, so it must be US-centric. Oh, we met at TwitchCon. Oh, very cool, Chozo Ninpo. Awesome. Welcome, welcome. It's good to have you here. Yeah, I don't know how US-centric this is, and there's also a bunch of different ones. So this is the one for evolutionary biology, which paleontology, you could say, kind of falls under the umbrella of, at least on the biology side. You also have geology, and I'm sure there's a different tree for geology. Yeah. There's all these different fields. Advertising. Donald Draper? Oh, geoscience is its own tree. Okay, the geotree. Anyway, it's interesting stuff. If you're interested in this, play around with that. Yeah. Classic Jurassic Park, Genesis, and SNES games. SNES. Oh, cool, Chosen Ninpo. I don't really do a lot of video games. If we're being open and honest here. I'm not really much of a gamer, but I appreciate that you were thinking of me. It's cool. Anyhow. And I'm glad you're enjoying the music. We've got about 45 minutes, give or take, before we want to jump into Thursday Birthday here, so I think maybe we'll, speaking of all these different names, we might continue with our Why Dinosaurs documentary here, and I might take this opportunity to run to the bathroom real quick. I will be right back. You could play as the raptor. Is that true, Chozo Ninpo? Hang on. That's intriguing. Honestly, one of the reasons why I usually recoil at the thought of dinosaur video games is that oftentimes they require you to do unkind things to dinosaurs in the game. If you could play as a dinosaur, it's an interesting idea. I might look into that. Yeah. Maybe home machine. What do you mean? We did some gaming earlier. We did Metazoa, remember? Yeah. This is real gaming. Yeah. Jurassic Park for the Sega Genesis, are they? Did they ever make a Sega Exodus? Sega Deuteronomy? Let's see if we can find a trailer for this real quick before I want to watch the thing while I'm running off to the bathroom. How long is this trailer? 2:41. I could do that. Yeah. This full documentary has just shown up on YouTube recently. We got a few minutes into it. Let me play the trailer, run to the bathroom. I'll be right back.
I think people love dinosaurs because they are big, they're bizarre, and they're extinct.
People are definitely fascinated by what they would have looked like, what they would have eaten, how they would have interacted with each other.
Dinosaurs are magical, mystical, amazing creatures.
There were giant animals like dragons that lived before mankind.
They walked in many of the same places where we walk today, but at the same time, there's so much we don't know about them.
You just start to wonder if these things existed, what else was alive millions of years ago?
Dinosaurs are just kind of everywhere. They're in kids' toys, murals, tattoos.
My name is Tony Campagna, and I am a dino addict.
Jurassic Park is the iconic pop culture version of dinosaurs.
It captured the imagination of the audience in a way that hadn't been done before.
They really changed the public perception of dinosaurs, and that has hugely benefited paleontology.
When I find a dinosaur, it's a pretty incredible feeling. It's a huge adrenaline rush.
This bone right here was laying right on the edge of a cliff. Literally, you can't walk without stepping on eggshells and chunks of eggs.
We have teeth, footprints, claw marks, everything you possibly need that could indicate allosaurs were feeding on some large animal.
What I'm realizing here is that the trailer for the documentary is just the first couple minutes of they're identical.
New data and new interpretations give us new ways of seeing things, better ways of understanding.
Molecular paleontology is a young science, but it's really going to take over paleontology.
CT scanning is providing us this amazing, amazing glimpse into dinosaur fossils that we've never really had before.
Paleontology is always the first science that any kid is exposed to.
Yeah, this is where we paused. Here we go. Okay.
Exposed to. They might not go into paleontology. They could go into health sciences or engineering or anything else.
The study of paleontology and dinosaurs in particular is extremely relevant to the issues, the crises that we are facing as a society.
There is something about dinosaurs that is humbling for us. We are part of this massive ecosystem, a family of living things.
Dinosaurs are the ultimate symbol of prehistoric life. They allow us to understand that life on Earth is temporary.
How can you dominate the world so completely and then lose it? And what does that say about our own success?
My name's James Pinto. For as long as I can remember, I've been into dinosaurs.
You like the pterodon that's on your shoulder?
Yeah, is that my pet?
Yeah.
I played with dinosaur toys, went to natural history museums.
No, excuse me, that's a pterosaur right there. It's not actually a dinosaur.
And made lots of dinosaur art, but I just never really grew out of it. From an early age,
And Hanaconda says that might have been my earliest exposure to science. It's true for so many different people, and that's actually a thing that I want to work on this year. I sent an email to Rhacodactylus about this yesterday. Longtime viewers already know what I'm talking about here, but there are so many different people who were first exposed to the idea of science. Really, they first fell in love with the idea of learning through dinosaurs at a very early age. As a dinosaur paleontologist, I hear this a lot from different people. I first meet somebody, whether they're a doctor or a lawyer or a historian or a librarian or a chemist or a teacher or a dentist or whatever. So often when I meet them and I say, yeah, I work on dinosaurs, they go, oh, really? wow, I was obsessed with dinosaurs when I was a kid. Those are the first books that I read. Or it was the first thing I really, truly got excited about. For so many different people, dinosaurs are this way of getting into the idea of learning. There's this phrase that you hear sometimes that, like, oh, you know, paleontology, dinosaur science, it's cool or whatever, but, you know, it'll never cure cancer. And I always go, what? What do you mean? It very well might. In the sense that if there ever is a cure for cancer, it very well might be discovered by someone who first went into cancer research because when they were a kid, they fell in love with learning because of dinosaurs. You know what I mean? So much of the wonder and joy of learning that's taught to children, like, this is done through dinosaurs. Dinosaur science, I think, has an outsized impact on our world. There's not very many people studying dinosaurs around the planet, and I happen to know a great many of them. As we'll see as we continue this. But those folks do have an outsized impact. They're getting people interested in science through dinosaurs, interested in learning through dinosaurs. So this project that I want to pursue, I think it would be wonderful to get survey data on people in different academic fields. Not just scientists, but historians and philosophers and dentists and medical doctors and engineers and lawyers and people, you know, who are in knowledge fields. And just ask them, how many of you first got into your field because, well, you really liked dinosaurs when you were a kid, and that was your first real introduction to learning? Anecdotally, it seems like it's a lot of people. It'd be nice to have numbers on that. And I think that would be a really cool thing to publish on. And so that's a project that I really want to pursue this year. Oh yeah. Do you remember Play School Definitely Dinosaurs toys? Maybe, Joseph. I'm not sure if I... I do! I had some of these. Yeah, I had the Ajkaceratops, and there was some kind of ornithomimid, too. This one! Oh, man. Yeah, Struthiomimus. I never had the box. These were, like, hand-me-downs that I got from somebody else. But yeah, that was, this was definitely part of my childhood. Yeah, the Ajkaceratops here. One of the few, like, Ajkaceratops models that have ever been produced. But yeah, that's this dinosaur right here. Is Ajkaceratops. Dangerous Alien, thank you for the follow. Welcome, welcome. It's good to have you here. So yeah. Boop the snoot. Okay, here. Here. How's that? You had a ton of those as a kid, says Chosen Info. These were not cheap, I don't think. So, good for you. You were fortunate, it sounds like. I had two of them, and neither of them were in the original packaging. I think they may have been hand-me-downs from, maybe from... I have like 3 older cousins, and these may have been from... This might have been from Stephanie and Ryan, maybe. I can see that being the case. Anyhow. Let's see here. Yeah, that is dinosaurs, but technically, Anaconda, yes. All birds are dinosaurs, but that's not exactly what I was talking about. And I like that that's a cool way to get into science. But yeah. shows this as I love how the commercial promotes how tough you can play with them because they're strong toys. Let's look that up. Here's a commercial.
At Play School, we know kids love our dinosaurs because they've made them the most popular ones in history.
We've got Play School dinosaurs are big and strong and tough. Spines and teeth and tails, jaws and horns and sails. We can play with them real rough.
And now we've made 8 more just as big and real with
there?
parts that move and cavesters too. Play School's definitely dinosaurs.
Play School dinosaurs are big and strong and tough. We can play with them real rough. Ah, scared you, didn't I?
Interesting. Yeah, that's funny. That may have been a little bit after, or a little bit before my time, rather. Because I got some of those as hand-me-downs. Again, the Psittacosaurus and the Struthiomimus. I like how the Struthiomimus, the beak is... They're like, it's got a bird beak? Okay, give it a bird beak. It's got a ridiculously birdy beak. Like a robin or something. What? You said give it a bird beak. It's got a bird beak now. Anyway, that's funny because this was the picture of ornithomimid dinosaurs from what, the late 80s, earliest 90s. Nowadays, our picture of this animal is a lot more like this. It's at once much more bird-like and
I'm interested in your island. It's got nothing to do with oil. I'm a paleontologist.
City Word Lion, thank you for the follow. Welcome, welcome. Good to have you here. But yeah. Anyway, it's like Homer's stubble. I kind of like that, Claire, actually, yeah. It does look like Homer's stubble. I like that analogy, Claire. I can see it. Yeah. Anywho. Fun stuff. Anyhow, let's get back to our documentary here, and we'll see what other discussion this prompts. Again, that's the beauty of a broadcast like this. It's live, interactive. You never know what's going to happen.
Rocks and shells and various types of fossils. I even won some awards at the county fair.
Nice. That's also how Jack Horner kind of got his start in science. Is he ended up winning his science fair when he was in middle school, I think. Let's see if we can find that actually. It's gonna take us months to get through this documentary at the current rate. Do we have any people with dyslexia here in the chat? Because this is all about Jack Horner and how dyslexia kind of shaped his life and made him who he is in a lot of ways.
Look at it. I sort of had a different view of my life. When I was 8 years old, when he was trying to teach me algebra, I actually found my first dinosaur bone.
He's talking about his dad.
Year. And that was a pretty big occasion for me. And I went out, my mother would take me on drives and and take me out to the sites. And so I would go out and collect dinosaur bones, even though I was failing all of my classes in school. And when I was 12 years old, I built an exhibit in our library, and it's still there.
I'd love to go see this in
And so
Shelby,
I
Montana.
would go to the library and read all the books, and not read them, but look at all the pictures, determine what I thought I had, and label all the fossils. And then, and I continued to do that through high school, and during, when I graduated from high school, I won the science fair, and that was actually how I got to college. I was invited, and so I went in 1964, and I studied geology, zoology, anthropology, and botany. And I actually took all the courses that were offered in all 4 of those departments. I mean, when you flunk out every quarter, it doesn't really. So here's the key. Now this is worth telling your students.
This is good advice.
The key is that if you change your major after you've been kicked out, then those people in that department don't really know. And so I would change majors pretty constantly.
Here's a link here. I've shown this to people with dyslexia before. They're like, this is one of the coolest things I've ever seen, you know? Jack talking about this from his perspective. Dyslexia not as like a disability, but almost like a superpower in a way. Not to be too cutesy about it, but yeah. Here.
I still, obviously couldn't read, so I didn't do well there. And then I went through, like everyone else in this room, I'm a little suspicious of the non-dyslexics in here. But I'll get to that later. All right, so I'm just really curious as to why you're here. I mean, seriously, unless you're trying to get our secrets from us. Anyway.
Well, here, let me, one more thing. Let me pull up, yeah. So, dinosaur eggs.
It's a conversation after this, all right? So, dinosaur eggs actually had been found in the 1800s. And so, dinosaur eggs had been found in the 1800s. They'd been found in France. They'd been found and then in the 1920s, they were found in Mongolia, and some were found in China. And I've started finding these eggs in the 1980s, and I was the first person to find a dinosaur embryo.
Yep.
A little skeleton of a dinosaur inside the egg. Now, here's our dyslexic question. Dinosaur eggs were found in the 1800s. First dinosaur embryo was found in 1983. What advantage did I have over everyone else in the world for all those years? I had a hammer. That's all there was. I had a hammer. For all of those years, people had... Now, see, this is the problem with reading.
Glue is cheap.
Reading is really
Makes
overrated.
an interesting point here.
About it. People had convinced one another that they shouldn't break eggs open because eggs are precious. And so no one ever broke an egg open. A dinosaur egg. I even went to museums and I said, can I just break one of your eggs open? And they said, no, you can't break your eggs because they're precious. And I said, it's just like having a present that you never open because it's so pretty.
So, anyway, yeah. I worked under Jack at Museum of the Rockies in Montana. And that was pretty cool, you know? Jack's got interesting perspectives on things. He comes up with new ways of thinking about problems. And I think that's important. I love reading. I'm not dyslexic. Big respect to people who are, obviously. But reading is a great way to learn about what's known about a subject, but you gotta take it with a grain of salt sometimes. Whether it's about ideas that eggs are precious, or about ideas that, like, oh yeah, of course, Rhabdodonted dinosaurs or ornithopods. If you just take everything at face value all the time, you know, that can lead you astray, especially in science. So yeah. It can be helpful in a you could do it way, but it can also backfire. Exactly, Charlie's Dragon. Yeah. And like most swords, it's a double-edged one. Not too many swords only have one edge. Gonna get a dozen people in the chat going, well, what about katanas? But, yeah. But anyway, experience is a learning phase. Exactly, Sparky Buggers. Yeah. I wasn't going to say anything, says Claire. Yeah. Anyway, again, if you're interested in this talk, there's a link to it right there in the chat. Anyway, we managed to get 3 minutes and 12 seconds into this documentary so far. And we're going to start up Thursday Birds Day in about a quarter hour, so let's continue.
I was 13. My dad...
And is Jack retired? Does he still do stuff? Yeah, he's still publishing papers, still co-authoring stuff, Little Pink Pony. I think he might still be teaching at college in Southern California. Jack still does field work on occasion. He's still active in the field. Yeah.
Dad took me up to UC Santa Cruz to work on a science fair project with some geologists. We used actual dinosaur teeth and a mass spectrometer to try and figure out how much time Spinosaurus spent in salt water compared to freshwater. The experiment took first place in the California State Science Fair later that year.
That's pretty neat. And what's clear too is this guy had seems like he had a lot of support from his parents about this. They're really encouraging him to pursue this passion. It's neat stuff.
And I even got to meet the mayor of my hometown.
Very cool. Simi Valley. Wow.
After that, I couldn't wait to get out into the field. So I started spending a few weeks every summer hunting for fossils on private ranches in the Badlands of South Dakota and Wyoming. At 16, I started volunteering at the La Brea tar pits as a docent and preparator. I spent countless hours cleaning asphalt off the bones of mammoths, saber-toothed cats, giant sloths, and other prehistoric creatures. My dad's a filmmaker, so I asked him to help me make a documentary about dinosaurs. We set off for some interviews with paleontologists, amateur fossil hunters, artists, toy collectors, and a state senator. I wanted to learn how to become a paleontologist and what the job entails, but I also wanted to understand why people around the world are so fascinated with dinosaurs and have been for centuries. How and where did it all begin? The very first
I love that this is we talk on this channel a lot about humanizing scientists to the general public, and this is a good way to do that, you know? It's like this is going to be a little bit of a who's who in dinosaur paleontology. That's neat. I like that a lot, you know? That's really important, especially nowadays. So, I think this is cool. You know, those outlines around the skull, that was pretty cool, Charlie's Dragon. That neat little animation-y bit like this.
Started spending Dakota and Wyoming prepared. I spent countless hours cleaning asphalt off the bones of mammoths.
Yeah, there we go.
Saber-toothed cats.
That's It's neat. And it's like, it's not super high effort, like, just a little bit of rotoscoping. Neat stuff. Anyway, let's continue.
The very first interview took place down the street from my house, at a unique hobby store that also happened to sell fossil replicas. The owner is a walking, talking dinosaur encyclopedia.
Our discovery of dinosaurs, back in the Middle Ages or even back into the times of early man, the fact that we find a dinosaur or a footprint in China, Mongolia and stuff, that whole area is just a wealth of fossil finds. There's no doubt in my mind that dinosaurs, were believed to be the dragons and the different things that we put into our mythologies and stuff.
I always push back against this idea because we don't actually have good evidence that that's the case. I know people really love this idea that, like, oh yeah, dragon legends were inspired by people finding dinosaur fossils, but we just don't have good evidence of this, Mark Whitten talks about this a bit. Dinosaur fossils and Chinese dragons, ancient association or modern wishful thinking? I'd encourage you to read this if you're not convinced. The thing is, like, fossils are... they can be pretty arcane. Difficult to study. It's extraordinarily rare that you find, like, a fossil animal laid out in the ground, articulated, and you can see instantly its body shape and know what it is and all of that. Like, it just... anybody who's ever done paleontological fieldwork, you know this firsthand. When I'm walking around with a camera out in the field, pointing it at the ground and showing you fossils, it could be really tricky because even with a camera right there, it's like, it's really difficult to tell rock from bone, and it takes a practiced eye to be able to tell the difference, to be able to interpret. You've got to have a lot of knowledge about osteology to know, okay, well, clearly this is the anterior part of a vertebral centrum, and this. It's not the sort of thing that, like, you just see in the ground and you know what it is, So, yeah. There's an interesting book about this, too, that I can recommend. So check out that Mark Whitten article if you're interested in this kind of thing. But also, Bill Center wrote a book about this. This is mostly aimed at, like, I guess, like, internet-addled conspiracy theorists and people who have been duped by TikToks and stuff like that. Like, oh, well, dinosaurs, those are made up, but dragons are real. He wrote this book kind of to give people the real story about that kind of thing. But this talks about how a lot of the dragon legends from around the world, it's only in our modern day that we call all of these things dragons and think of it as a singular phenomenon, when it's not. These are just, like, different kinds of myths and legends and stuff that people in different cultures around the world came up with that don't have anything at all to do with one another. Today, we throw them into this wastebasket that we call dragons. But it's... it's a modern phenomenon. So yeah, Phil Center is the author here, Claire. Yeah, this is certainly written for a lay audience. It goes into some really cool detail. But yeah, it also debunks a lot of, like, creationist ideas about fire-breathing hadrosaurs and stuff like that, too. This is a good one to have on your shelf if like me, you're doing science outreach all the time, and people come in from across the internet and go, well, I saw a TikTok that said that dinosaur fossils are actually dragons, and the Smithsonian is trying to hide it along with the lizard people and stuff, Yeah. Okay. It says, bro, there's dragons on Shrek. They must be real. Yeah. Dude, my Uncle Shrek told me about them. Are you calling him a liar? Though anyway, this is book newish. Yeah, I think it just came out last year. Anywho, not to, again, I'm not trying to rain on anybody's parade. I know people love dragons, but the idea that they have anything at all to do with dinosaurs, I think, like Mark Whitten argues, is probably mostly wishful thinking. So yeah.
We have today.
People have been finding fossils throughout history and making all kinds of assumptions about them. For example, a mastodon skull has a large hole for the trunk, but you can easily see how someone might have thought it was a giant one-eyed cyclops.
And that maybe there's something there. Although it wouldn't, I think these were like different kind of proboscidean in the Mediterranean. Not necessarily a mastodon. When I think of mastodons, I think of the American mastodon. Anyway, I'm just being persnickety at this point.
Especially if you found it along with some huge limb bones. But when and where did modern paleontology actually originate?
Oh, we talked about this today. In Europe, in the 1800s. Cuvier and Mantell and Owen and Buckland.
Paleontology, as we know it, started in the British Isles during the early 1800s. Fossils of prehistoric sea creatures were found on coastal cliffs like these. Mud and sand covered them and preserved them from natural decay. But after millions of years, these plants and animals have been replaced by rock and are exposed after heavy wind and rain. Paleontologists such as Dr. Dean Lomax are highly skilled at finding and revealing them.
Ammonites are beautiful. Look at that.
Oh, wow. Look at that. As a complete ammonite. The first time anybody has seen that in 180 million years. Right in the center, it's got these whorls that go round and round and round right to the end, where the living chamber here, where you've had the little animal living inside the shell. Little arms and tentacles would have been right here. Beautiful. This place here, I used to come here when I was younger. It was a very, very famous location, and I used to collect lots of fossils here, and I essentially honed my skills.
So those are whale dentaries right there. Sorry, whale mandibles. It's a mammal. You don't call them dentaries, you call them mandibles on a mammal. Yeah, whale lower jaw. It's probably a blue whale. Well, it could be a fin whale.
My skills as an avid fossil collector, you know, going on adventures down here. And of course, talking about coastlines in the British Isles, it's difficult for me not to mention Mary Anning down on the Dorset coast, who as a little child went out and collected thousands of fossils. I like to see myself as a mini Mary Anning when I was here collecting material as well. And she found, you know, many of the most incredible fossils down in Lyme Regis in particular.
Yep. She was an amateur paleontologist that lived in the UK in the early 1800s.
And calling her an amateur paleontologist really kind of isn't fair. She lived at a time before there were professional paleontologists. The word paleontologist didn't even exist until like shortly before her death. People called themselves natural philosophers or naturalists if they were studying the natural world like fossils. But yeah.
She was one of the first people to really appreciate the Jurassic coast. She was not allowed to be part of the scientific discussion at that time because she was a woman, but she made huge inroads in allowing women to be involved in science, and she is definitely one of the most iconic paleontologists that I can think of.
Yep. So Mary Anning, we've talked about her many, many times. We always do a big stream celebrating her life on her birthday, May 18th, I want to say. She is almost like the patron saint of paleontology. If there's one character in the history of our science who is universally beloved, it's Mary Anning. Yeah, we do a special stream about her every year. Let me find the latest one here from last year. Anyhow, Anyhow, I got to visit Lyme Regis when I was in England back in November, and there's a lovely statue of Mary Anning. That I was lucky enough to visit and also photogrammetrize. It's able to make a 3D model, print it. Well, here we go. Here's my 3D printed Mary Anning statue, which I'm really excited to have up on our wall for this year's Mary Anning and birthday stream. Yeah. Very excited about that. And, yeah. I've made some modifications to these files too, so it'll be easier to print, and at some point before Mary Anning's birthday, I'll put these up on Sketchfab, so if you'd like to, you can download this yourself and 3D print it if you have access to a 3D printer. Good stuff. And Mary Anning bobblehead when? I don't know, Claire. Maybe I'll focus on the leatherback turtle bobbleheads for now. With googly eyes. See, I don't want to get disrespectful about this, you know? Tremendous reverence for Mary Anning here. I don't want to turn her into a caricature, you know? Anyhow, Mary Anning.
Not only do we find the ammonites and other types of fossils here, we also do find dinosaur footprints here. And it's a very different environment, and it's slightly younger than the material, the 180 million year old stuff of the ammonites and things. This material is about 170, 160 million years old. And what you're looking at here is a massive block of sandstone that's fallen down from right at the top of the cliffs. And this footprint, this is by far the best one. So you've got a three-toed impression here. You can easily see 1, 2, and 3. Now what you're looking at, it's not a true track, so it's not where the animal's left its footprint and then that's preserved. Instead, the footprint's been left behind, that's been baked by the sun, it's hardened, and then that impression has been filled with another sediment, and then that's hardened over time, so you have what's called a natural cast of the original footprint. By looking at the footprint shape,
that was really cool, that little animation that they did there. That's really useful. I gotta remember that this is here. So next time I'm explaining this
impression has been filled with another sediment, and then that's hardened over time, so you have what's called a natural.
That's a lovely visualization right here. When I was on the Isle of Wight with Susie and Richard back in November, I found a dinosaur track like that. And Jeremy Lockwood, who is kind of the expert here. There's Jeremy there. He was like, yeah, it's a really nice one. I was very proud. There we go. Here's the track right here. There's the heel, there's 1 toe, 2 toes, 3 toes. Good stuff. Anyhow. And where's this documentary, says Wild Luna? I'll give you a link right here on YouTube. Check it out.
Of the original footprint. By looking at the footprint shape, compare.
What footprint is it of? Probably an iguanodontian dinosaur, so something maybe similar to well, Mantellosaurus or a close relative, somebody like this. So those are the hind feet that you're seeing there. Yeah, dinosaur kind of like this.
With the feet of other dinosaurs, we know that this has been made by a stegosaur type of dinosaur, so those armored.
Oh, the one that he's got. Yeah, that's right. Stegosaurs have 3 toes on the back, and that is a lot more short and squat. Of course, that's a stegosaur. Yeah. Okay. Yeah, nice. Very cool.
Feet of other dinosaurs, we know that this has been made by a stegosaur type of dinosaur, some of those armor-plated beasts from the Jurassic. It's a pretty awesome fossil.
Paleontology and fossils presented the extraordinary idea that there were once animals and plants that are now extinct. Soon, people were finding fossils from more of these extinct creatures, including the first discoveries of dinosaurs. The first dinosaur to be named and described was Megalosaurus by William Buckland in 1824. The next year, Marianne...
So I got to see the original Megalosaurus jaw. In the museum in Oxford. At the end of that trip, which was pretty extraordinary. Tears to my eyes. That's why I look so goofy right here. I can barely contain my enthusiasm, but that's it. This is the 3D print of that. That's the original right there in Oxford. Okay. Yeah. It's at the Oxford Museum of Natural History, Anaconda. Yeah. Here it is here. But that is... Here we go. At the Oxford Museum of Natural History. There was also a leatherback turtle on display here, which I didn't even look at because there's so many other things to see and we had so little time there because of traffic and everything. But yeah. Yeah. Called it the Oxford Museum, but what's the actual official name? Oxford Museum of Natural History, right? It's not the Pitt Rivers Museum. Yeah, Oxford Museum of Natural History. Oh, thank you, Claire. Cool. I appreciate that. Nice. Anyway, let's continue here. Yeah, here's the iguanodont teeth.
Anna Intel discovered some unusual teeth, which her husband Gideon named iguanodon.
So this is what Susie mentioned during our interview today. Some of the first dinosaurs to be discovered in England. This is one of them, and those teeth right there. Got to see those as well. Which, again, just mind-boggling. It's like a religious experience, you know? Incredible. Yeah. Those are the original iguanodont teeth. Pretty extraordinary.
Intel discovered some unusual teeth, which her husband Gideon named iguanodon. And later, he discovered and named this armor-covered herbivore, Paleosaurus.
But nobody could work out, couldn't put their finger on exactly what these things were. They knew there was some really weird ancient reptiles, but what were they? This is when we enter Sir Richard Owen, the founder of the Natural History Museum in London, because Owen examined those 3 dinosaurs as well as other remains, and he actually coined the name dinosaur, meaning fearfully great or terrible lizard, in 1842. So effectively, you know, we could say that the dinosaurs are a British invention.
Fast forward a decade
Oh man,
later, and we had the world's first dinosaur.
Don't let the TikTok conspiracy theory people hit it like, oh wait, the Brits invented dinosaurs? Dude, bro, I heard it in the documentary.
Or sculptures created by Benjamin Waterhouse Hawkins. Over 24 dinosaurs and extinct prehistoric creatures were put on display in Crystal Palace.
We talked all about this.
The park opened
just
in
a few days ago.
1854, and this was the first time that members of the public were able to see scientific ideas that before then had been hidden behind closed doors. The artist's idea was to bring together entertainment and education into the same space so that people would see something and start asking questions about it and learn something about the world around them.
The sculptures aren't representative of how we might imagine the dinosaurs and other extinct animals to look today. But in that is part of the story of science. New data and new interpretations give us new ways of seeing things, better ways of understanding, but it's always a sort of self-improving process. It's a way of knowing. There is no absolute truth out there through science, but it's an improved understanding and improved knowledge.
Yep, it's an ongoing process.
In
1853,
just as the park was being finished, they hosted a dinner inside one of the half-finished sculptures. And they brought together scientists and artists and sponsors and press barons all to celebrate the finishing of this great project.
Yeah, good stuff. And Caden says, didn't you say dinosaurs didn't actually have vocal cords? No, I don't think so. Because if I'd said that, I would have been wrong. So, a lot of dinosaurs would have had a very different vocal apparatus than modern mammals. So, they wouldn't have necessarily made sounds with their larynx. I'm a little unclear on whether some dinosaurs would have had a larynx or not, but if we're trying to think about dinosaur vocalizations, I think it's important to let your starting point be birds and crocs. This kind of gets into this framework that we use sometimes for framing these questions. The extant phylogenetic bracket. There's something that's unknown for dinosaurs. Like, say, what kind of vocal apparatus did they have? What's the soft tissue there? It's not preserved. Well, we look at their closest living relatives. Crocs, who are kind of like cousins to the dinosaurs. And then birds, who literally are living dinosaurs. And we can use them to kind of frame our thinking about these questions, you know? So a lot of modern birds, they use what we call a syrinx. It's a different kind of structure for producing their sounds. Crocs have got a different apparatus. Dinosaurs, kind of somewhere in between. A lot of discussion about this. I'd love to be able to talk about this more in depth, but I'm just realizing it's after 5 p.m. We gotta get into Thursday, Birds Day here, and talk about these living dinosaurs. So why don't we go ahead and jump into that, you know? Without further ado, it's time to start Thursday, Birds Day. So we'll maybe continue that documentary another time. I'm enjoying it so far. I think it's pretty nifty. But, yeah, for right now, we gotta start up Thursday, Birds Day. Let's get into it.
Hold on, something's coming out of here. Look, there's a bird, dude. It knows what's good. I'm telling you, I just heard it inside.
I don't care if Monday's blue, Tuesday's gray and Wednesday too. Thursday, I don't care about you. It's Thursday.
Thursday Birds Day.
Birds are all around us in everyday life. But most of the time we hardly even notice them. Thursday Birds Day is a step toward correcting this oversight. Do you want to be part of Thursday Birds Day?
I don't know.
Here's how you can contribute. Go outside during the week and pay special attention to the birds around you. See if you can take a picture of a bird. It doesn't have to be a good picture, any old photo will do. Upload the picture to the Discord and we will discuss it on Thursday. Simple as that. Thursday Birds Day is an invitation to go outside and appreciate the grandeur of the natural world. It's a reminder that, since birds are theropods, dinosaurs still enrich our daily lives.
It's great!
And finally, it's a celebration of the amazing history of life on our planet. So, happy Thursday Birds Day!
Happy Thursday Birds Day indeed, everybody. You ready to get into some of these lovely theropod dinosaurs that chat has given us over the past week? Let's take a look at some of these photos. Let's see. From Cacklin's Wharf. Oh, who is this? This is some kind of heron or bittern or something? Okay. Ooh. Stretchy birds is clever. Bittern, very nice. Or roardum, as we call them. Cool. Let's look up bitterns here. I think they're part of Ardiidae, the heron family. Let's take a look. Bitterns. There we go. 12 living species. They make fun noises, says Hanaconda. We'll have a listen. Yeah, they are indeed part of Ardiidae. The heron family. Very cool. Cool stuff. Cool stuff. Here, let's have a listen. What do bitterns sound? Great bittern male song. Let's hear that. What do you sound like? Make a noise. So cool. What? That's so neat. Oh man, that's cool. So to get back to that question, what did dinosaurs sound like? Well, dinosaurs today, modern birds, make a whole variety of different sounds through different means. There was that bill clacking like you heard right there. And there was that sound from deep in the chest. Listen to that. It's like a tuba. Very cool. Oh man, that's weird. I love it. Here's a link to that video here. Neat stuff. Anyway, Ecclesworth saw one of these and photographed it for us. Super cool. Yeah. And Kamiali says the shoebill is fascinating. It absolutely is. We have 2 different shoebill emotes here. That's another bird who makes some pretty wild sounds. And then let's Sounds almost like a heavy machine gun or something. Here, listen to this. This is Balaenoceps rex. How cool is that? It's called bill clacking. Really neat. Yeah. Imagine hearing that while camping, says Kamiali. Yeah, I mean... wonder what it is, I'm sure. Yeah. Isugen says that's truly a dinosaur. I mean, literally all birds are. The diversity of dinosaurs is pretty astonishing when you really think about it. Everything from stegosaurs to crows. They're all dinosaurs, you know? Pretty neat. Pretty neat. Anyway, thank you, Cacklinser, for posting that. Good stuff. And Mr. 88 has got... I love these big farm ducks, or are they farm geese? Some big domestic member of Anatidae, I think. Hanging out under an umbrella. You know, sometimes birds are really clever. They're like, yeah, I'll make use of that. Pretty cool. Pretty cool. Ducks, I think, says Charlie Dragon. Nice. Yeah. Nifty. Thank you, Mr. 88, posting that. And you've also got, oh, is this another bittern or some kind of heron? It's some member of Ardeadeae are herons and egrets. Nice. Very nice. Wait, ducks are called Pekin ducks. Is that true, Mayor's Max? Huh? Cool. Let's see. More from Cackling Dwarf. Okay. These are really, really nice. If you... Oh, man. If you're a fan of travel through videos, it's like, what would it be like if I were to take a quiet stroll through some lovely scenery in the Netherlands? Well, Eckelsdorf has got you covered. Spots of birds here. Let's have a look. Oh, there's birds already, right off the bat. Nice. Just positively aggressively bucolic. Look at this. Just, oh man. Just too scenic. This is nice. Very cool. Thank you, Tackles, for always posting these. These are fun. Oh, yeah. And there's either a cormorant or an anhinga. Given that this is in Europe, it's going to be a cormorant, huh? Very nice right there. Yeah, lovely. You know, when I say, go outside and commune with some birds for Thursday birthday, Cacklin's Wharf is like, yes. This is great. Nearly an hour of relaxing bird video here. Good stuff. Thank you for posting. Once again, good stuff. Yeah. Touch grass and appreciate the local Ajkaceratops. There you go, Alexander. Yeah. And Wild Luna says cormorants, bad spelling, and a swan, I think. Cormorant, I guess, isn't the easiest word to spell. Let's see. Oh, no, you've got... Are those buffleheads there? Very cool. I think those are buffleheads with the white cheeks. Maybe. Yeah, might be, might be. Or could they be golden eyes? Dangerous of birds. I don't think it is a golden eye. The white patch is too small on the cheek. Pretty sure these are buffleheads or somebody similar. They're not golden eyes. Anyway, thanks for posting there, Wildwood. Saw a common golden eye last week and a tough-legged hawk. Rough-legged hawk? Tough-legged hawk? Very cool, Neverwinter. Oh, and Neverwinter says buffleheads. Well, well, well. Ah. I still got it. Rough-legged, not tough. Okay, yeah, I figured. Like, I've never heard of a tough-legged hawk before. But, you know, I don't know every bird. But buffleheads, are they close relatives of the golden eyes? Say that genus name Bucephalus sounds familiar. There we go. Yeah. This whole family is called the buffleheads. Or the golden eyes, rather. Barrow's golden eye, common golden eye. Related to the scoters. Okay, cool. Golden eyes. Slappers only. Yeah. Anyhow, Mr. Double 8 has got a big psittaciform bird. This looks like some kind of macaw here. Nice. Dinosaur Dave has got... Oh, sharing because you don't see juvenile cassowaries often. This is true. This being a young female is even cooler. Well, let's see if I can get this to work. On TikTok, so I don't know if it will. Oh, there we go. It's working. Oh, cool. This is really neat in that cassowaries don't actually develop their full-on casque until they're nearly fully grown. Raptor style. Well, it is a Maniraptoran, as we already established. Alexander Morrison, but yeah. That's really neat. What a cool animal. I love cassowaries. They're so cool. Lovely. lovely animal. They're so neat. And yeah, so there's what the adult looks like with that fully formed cask on top. Big hollow crest. Yeah. Neat stuff. Which, reminds me of... with, cassowaries here.
At the University of Pennsylvania, actually realized that dinosaurs grew kind of like birds do, which is different than the way reptiles grow. And in fact, he used the cassowary as an example. And it's kind of cool. I mean, if you look at the cassowary, or any of the birds that have crests on their heads, they actually grow to about 80% adult size before the crest starts to grow.
Just like you were saying there, with that cassowary from that video, it's not a small bird. It's growing. It's like maybe 60, 70, 80% adult size, and that crest is only starting to come up.
Now think about that. I mean, they're basically retaining their juvenile characteristics very late into what we call ontogeny. So allometric cranial ontogeny is relative skull growth.
So anyway, interesting talk. The whole Nanotyrannus part of this talk may no longer hold up as well as it once did, given recent publications, but important stuff. Anyway, yeah. Thanks for posting there, Dinosaur Dave. This is cool. And Mayor Space has got a Victoria crowned pigeon at the Toledo Zoo Aviary. Ooh, nice. Look at that crest. So as a bird, you can either develop a feathery crest like this or a bony crest like a cassowary. The advantages to a feathery crest is, well, you can alter it. It's not nearly as expensive as, like, developing a bony crest on your head. It's also much more mobile. So you can move it around based on your mood or what you're trying to say. Harder to do that with a bony crest. Yeah, pretty neat. What a gorgeous animal, you know? Very cool, Mayor Space. Very cool. Thanks for posting. Mommy Does says, I have no idea what this bird is. I managed to snap this pic against the storm, rolling in before it flew out of view. Looks to me like a crow or a raven. Yeah, that is a really cool picture, though. Dramatic. Claire Burr says, gull. Yeah, maybe. Could be a gull. Gull likes his dark material. Okay. Yeah, I could see that. The wings are a little thin, like front to back for a crow or a raven. They've got like a longer wing surface, broader wing surface. This could very well be a gull. Neverwinter says, I was thinking turkey vulture. Really? Does it have the right angle, though? I don't know. It's this indent right here along the anterior surface of the left wing that... This says gull to me. But... I don't know. You would probably know better than I would, Neverwinter. Yeah. Yeah. What area was this taken in, though, says Caden? Yeah. It's a good question. For now, we'll say, mystery bird. Thank you, Poppy Copy, for the follow. Welcome to Paleontologizing. It's good to have you here. Yeah. Birds are hard to ID when flying away. Yeah, when they don't want to be ID'd, good luck. Yeah. Mr. Double Eight has got... What is this? That's not a bird we have where I live. I'm not sure who this is. That's pretty cool. Huh. Neat. Black on brown. Yeah, I don't know who that would be, Claire. Mysterious. Grackle. Yeah, I don't know who that is. Interesting. Oh, from a bird far away with its back turned to right in front of the camera. From a snowbound Holland balcony. Very cool. Thank you. Very, very cool. These are some kind of conure or other parakeet? Yeah, very cool. Charlie's Dragon says, parrots in Europe, still weird to me. They love to go feral. You know, and it's because of kind-hearted people like this who leave out food for them that they're able to survive without too much trouble, you know? And Hannah kind of says, you get them too? Yeah, we have them in San Francisco. And in other places throughout California as well. There's even a documentary about them. The Wild Parrots of Telegraph Hill, San Francisco. Good stuff.
How long have you owned these?
I don't own any of them, actually. They're all wild.
When he first called, what I was taken by was the fact that here's a guy that is beginning to understand the relationships between the individual birds, which is a very rare opportunity in science.
When Mingus is a bad bird, rather than putting him in the cage, I throw him outside. He wants back in so badly.
Hey, Mingus, wanna dance?
Well, I got me a roof, and I got me some clothes, and I eat real good, man, I overdose. When it gets dark, you know, I turn on the light, put on my shades when the sun's too bright. Every comfort for every
Watch this all the way through.
I still can't get me no peace of mind.
Good stuff.
This is San Francisco. It's too cold. I mean, it's strange enough that these parrots are here, but they're breeding too? That's impossible.
Hear that sound they're making?
That is surprisingly adaptable.
That's the sound they make when they see a hawk.
Yep, there it is.
After you
Red
leave,
shoulder dog.
what will happen to these birds? Do you think that they will take care of themselves in
Yes.
the wild?
I'm positive. I mean, their biggest problem would be people.
F-18 fighter jets.
In a certain sense, they're a lot purer than we are because we have a lot of things that bind us up inside and we play a lot of games that animals don't play. They're really straightforward. Come on, Mingus, let's go in.
That's the thing, when you see these out in the city in San Francisco, which is, of course, my neck of the woods. This is where I live. You hear them before you see them. They're really noisy. They're not the biggest birds. So yeah, you usually hear them before you see them. But yeah, I used to see them every day back when I worked in the city. And is the hype train email one of them? So these are cherry-headed conures, is this species that we have in San Francisco. Cherry-headed conure, member of the parakeet family. So I think they're originally from Oceania, Australia, or New Guinea, or somewhere like that. But yeah, it is the same. I don't know if it's the same species, but it's a close relative, probably, Claire. Here, cherry-headed conure, also known as the red-masked parakeet. That one's got a dark bill. I wonder if there's a closely related species. Red-masked parakeet. That's cool that this might actually be in San Francisco where this picture was taken. Red-throated, dusky-headed, sun parakeet. I think that's a golden-capped parakeet there with the dark bill. Yeah. I think that's Aratinga aracapillus. That would make sense. Neat. Hype squawk. I like that. That's good. Yeah. Good stuff. Anyway, Fake Dude's got these guys, and I don't know what kind of parakeet these are. I wonder if I can find them just perusing this. There's so many different kinds of parakeet who happen to be green. Olive-throated. Mitered, scarlet-fronted, white-eyed. Other parakeets. Yeah. Yeah, cool stuff. I love seeing that big pupil there too. These guys, it's really neat. They can control at will the diameter of their pupil, and they use that for showing off. They use it for communicating. I don't know what exactly they're saying with that, but it's neat how that works. Eye pinning? Is that what it's called? Eye pinning is when a bird's pupils dilate and contract from large to small. Holy cow. Did you see that? Here, one more time. Big?
Let's protect our fossils, because if they're removed, America loses them forever.
And Caden, thank you so much for that recurring subscription there. Welcome to the community. Thank you for that pledge of ongoing support. I really appreciate that. Good stuff. Awesome. Look at this. Whoa! Oh, that's so neat. Give me a variety of things, such as happy and excited. Very hey look at me behavior. Interesting. Okay. Cool. Anger or fear, a warning sign before a bite. So basically it means like, hey, I'm up here, whether it's I'm excited or I'm mad or I'm scared or whatever. Interesting. And you wanted the emotes nice, Caden. Well, enjoy. Player perfect comfortable. Interesting. Okay. Cool. That's really neat. Yeah, and this reminded me of that. Anyway, Fake Dude, thanks for posting. Static's got wattlebirds nesting in front of our yard recently. Unfortunately, they've done a much better job of hiding the nest than the wagtails. Well, good for them, you know? Neat bird. How cool is that? A wattlebird. And what a bird it is. I love this like furtive picture through the bushes. We see you there. That's a really well-concealed nest. Like, good job, you know? These birds know what they're doing. And I'll see you later, call me Ollie. Oh, next time I'm streaming is going to be Monday, I think, so hope to see you on Monday. And Chaotic Time Traveler says, Luffy, pronounced Luffy, thank you. My Indian ringneck is very excited about the plastic dinosaurs I got for Christmas. Nice. He enjoys carrying them around, cleaning them, offering them food and water. Aww. Oh, lovely. Very nice. Oh, good stuff. Very cool. Oh, that's awesome. And look, oh, this is so cool. This is from today. Holy cow. We've got a dinosaurian viewer, chat. How cool is that? Oh, man. Very cool. Thank you for posting, Chaotic Time Traveler. That warms my heart. This is lovely. Fantastic. Charcone has got the first Robin song of the year. Well, well, well. Not from this bird, unfortunately, but from the one behind me I couldn't find. Let's have a listen. Here we are. Nice. And it's an American robin. Turdus migratorius is the genus and species name. Who was watching earlier? He insisted on continuing watching. Nice. Chaotic Time Traveler. Nice. These are fun. American robin. Just like the Jimi Hendrix song, right? And Neverwinter here's a tufted titmouse too. See, those birder ears, they're impressive. It's pretty neat. Good stuff. Thank you, Charco. Alexander Morrison's got a big collection of avians this time. Well, well, well. Multiple long-necked and long-legged birds in the water seeking sustenance. Great blue heron, wood storks, great egret, glossy ibis, cattle egret, tricolor heron, and finally a white ibis. Very cool, with music by Brian Egg. Let's have a look and a listen. Nice. Yeah, look at all of that. Again, Florida's such a cool place. Wetlands galore. All kinds of cool, large birds walking around doing their thing. How neat is that? Oh. Got some bird directions here. Avian competition. I love that S-curve to heron necks too. It's just bonkers. Such flexible necks. Cool stuff. Thank you for posting there. Always a joy to see you. And Neverwinter has got, what is this? My goodness, a snow bunting, Plectrophoenix nivalis, foraging along the beach at Barnegat Lighthouse, New Jersey, December 2022. I believe this is a non-breeding female. The male is almost completely white in breeding plumage, but it's only when they're in the Arctic. Some birders refer to them as toasted marshmallows in this plumage. Well, let's have a look. Very cool. Very, very cool. It's clearly like a passerine bird. What are they related to? Probably an indigo bunting, I would imagine. Snow bunting. Snow bunting. Okay, there's multiple species. Oh, well, wow. So, you've got two species. The snow bunting and McKay's bunting are both part of, I guess, genus Plectrophenax. That's a mouthful. Neat. And they're related to other buntings, sparrows, finches, etc. That makes sense. Little passerine birds. Oh yeah, black-headed bunting. It's the one when we zoom out to, when we zoom all the way out to Tetrapoda, I think, black-headed bunting is one of the ones that's on the little emblem there. Tetrapods, lungfishes and tetrapods, lobe-fin fishes. The black-headed buntings, not only are they a kind of bunting, they're also a kind of lobe-fin fish. That is not a joke. Yeah. All birds, and indeed all reptiles, plus the amphibians and the mammals, they're all a kind of lobe-fin fish. It's pretty neat. That'd be cool, Alexander Morrison. Maybe next week. Anyway, thank you, Neverwinter, for posting this. Good stuff. Beautiful photo, as usual. And man, you must have gotten the camera way low down to be able to take this. I've got a bird's eye view of one bird from another bird on the beach. Sometimes a bird's eye view could be from the ground, you know? In the sand, says Claire Burr. Yeah. Let's continue. And Dr. Tara's got a mockingbird. Well, let's see what it sounds like. What's it saying? Science. Cool. Let's play that again. It's amazing what they can mimic, you know?
Science. Ha! Got him! Ha!
Wow. Pretty neat, you know? Amazing. Gleiber's got a great crested tern, possibly? Same bird followed, flew ahead of us on our walk along the beach for quite a while. Nice. Terns are neat. I like their long bills. We get least terns here in the Bay Area, along with Forster's terns and great tern. I forget. Anyway, but the least terns are rare and protected. They're very special. Good stuff. Like roseate terns, says Anaconda. Let's take a look at our terns, shall we? But first we here get some proper audio. Terns. Gulls and terns. There we go. Terns and noddies. What did you say? Roseate terns, says Anaconda. There we go. Nice. That is a good looking tern. The least tern is the one that's very special here in the Bay Area. Naughties are basically a type of tern, says Neverwinter. Yeah. Yeah. Cool stuff. Anyway, thank you, Wyber. This is a lovely photo, by the way. Oh, boy. The majesty of this theropod. They fly so low to the ground that their tips of their primaries are like contacting the sand practically. That's great. Good photos there, Gwyber. Good photos. And Salamander has got a flock of Brandt's geese, I think, and Canada geese at Colt State Park. Really? Canada geese, very common here, but Brandt's geese too? Well, I could see that. Yeah, nice. Again, Canada geese are cool for what they are. They're charismatic, even if they're pretty common in the U.S. nowadays. But Brandt's geese, neat. I don't know if we have these where I live. Brandt goose. Here we go. Oh, sorry, Brent goose? That's funny because Branta is the genus name. Brent goose? Huh. There's a, cackling goose. Different from the Canada goose and the Hawaiian goose. Interesting, Hawaiian goose is sister taxon to the Canada goose, sister species. And I like this. Branta canadensis for the Canada goose. For the Hawaiian goose, Branta sandvichensis? What? What? Does anybody know why that is? The Hawaiian goose. This might also be known as the nene. Branta sandvichensis. What? I think that's because, I think it's because the Hawaiian Islands used to be called the Sandwich Islands, but that might not be true, actually. There's the South Sandwich Islands, which are in the South Atlantic, but Sandwich Islands, disambiguation. Yeah, South Georgia and the South Sandwich Islands down in the South Atlantic. There we go, the name given to the Hawaiian Islands by James Cook in 1778. There you go. That's why the Hawaiian goose is called Branta sandvichensis. As we've talked about many times before, anytime you hear ensis in a species name, that means from that place. It's used to be the Sandwich Islands, so that makes sense. Named after the Earl of Sandwich. Exactly, Neverwinter, yeah. Anyway, very cool. Good stuff, Salamander. Thanks for posting. Yoda Kitten says, birds on the roof. Historic building across from Kilkenny Castle in Kilkenny, Ireland on February 27th. Kilkenny. I didn't realize that was a thing in Ireland. I thought that was just a Colorado thing. Crow's question in the beautiful Kilkenny, Ireland. Anyway, Caden, thanks for being here. Oh boy. Don't use ChatGPT to do your homework though. It's gonna give you the wrong answers. You're not gonna learn anything. Anyway, I hope to see you again soon, kid. Thanks for being here. But very nice, Cat Kitten. Who are those birds on the roof? I would guess a gull, but could be a pigeon. From this angle, I realize this is just because the photo's doing something wonky here, but it reminds me of the silhouette of a quail. Is anybody else seeing this? Is anybody else getting quail from this this silhouette? Claire says yes. Yeah. I'm not saying I think this is a quail. I don't know if they have quails in Ireland. It's our state bird here in California. It's the California quail, but I doubt that is a quail. It's probably just the light is making the neck look slimmer. Anyhow, cool stuff. Thank you, Chaotic Kitten, for posting. Anaconda's got a gray heron waiting near the squid stall in a food court in Camden, London. Very nice. Well, just waiting for some cephalopods, or as they say in London, cephalopods. Nice. Good stuff, Anaconda. Thanks for posting. That heron knew where to be, says Anaconda. Yeah. They're clever, you know? Kazashi says, I went to the Australian Reptile Park the other day while visiting the coast, and here's an Australian reptile to prove it. Emu dromaeus. Very cool. I had to shoo this poor chap away from an elderly couple trying to have their lunch. Yeah, well, if a big flightless bird wants to bully some people out of their lunch, who am I to stop them? I guess you might have a different moral code than I do. No, you're probably just trying to keep the peace there. I appreciate that. Kazashi, very cool. Emu dromaeus. The second largest living bird in the world, if we go by weight, I think. I think emus are the second heaviest after ostriches. Very cool. That does make me wonder if, you know, it goes in terms of this family of birds. I think it goes ostrich, emu, cassowary, rhea. Ostriches might not even be in the same family, honestly. Let's look. But I wonder if... Yeah, there we go. Ostrich. And then you have lesser rhea and greater rhea. And then cassowaries are over here. Yeah, I guess they're not all super closely related. There's other birds that are in between. You've got elephant birds over here, and you've got kiwis, and you've got moas and tinamous. But it does make me wonder whether the lesser rhea, I wonder if it weighs any less than like the largest penguins. Because I remember reading somewhere like, oh yeah, you know, in terms of different birds and how much they weigh, it goes ostrich, emu, cassowary, rhea. And it makes me wonder if there's any penguins that are heavier than the smaller species of rhea. Huh. Very cool, Anaconda. Giant squid rat, super neat. Oh, awesome. Cool. Anyway, thank you for posting, Kazashi. Good stuff. Oh, and that's our last one. Well done, everybody. And a happy Thursday Birds Day to us all. Excellent. And it's 6 p.m. Shoot, it is. I'm right on time to wrap up today's stream. Don't go away just yet. We're gonna raid into somebody else doing some science here on Twitch. But I had a lot of fun today, and I hope you did too. What a joy to be able to interview Susie Maidment. Yeah, I really hope she enjoyed that. I know I did, and I know many of you did in the chat too. Check out the VOD if you happen to miss that part, because it was pretty special. Let's go ahead and wrap up our stream for today. And we will put an Archaeopteryx under our credits here. And that was, no, not part of the SVP series. This was a separate thing, Claire, right after her paper. But, who else is live on Twitch right now as we start off our credits? Let's see. Oh, Nerduino's on right now. Well, let's go right into Nerduino, who I think might be doing a partner push currently. May have just started that off. There we go. Excellent. Nerduino is a fellow scientist, former NASA scientist, current astronomer. He's doing some science outreach right now, and I think might be starting off his partner push. We'll ask him when we rate in. Thank you, everybody, being named in our credits here. From new followers to the subscribers and the gifters and the cheerers and the resubscribers and the re-resubscribers. The re-resubscribers. Thank you, everybody, for keeping me here online through your financial support. It means the world to me. It allows me to do this full time, and I am incredibly grateful for that. Likewise to the moderators, do their utmost to keep this a safe and welcoming community for everybody. I appreciate that more than you know, and I'm hoping all of you have a safe and restful and fun weekend. I appreciate you coming in here and hanging out with me and talking about the history of life on our incredible planet. I'm grateful. And I hope you'll join me again on Monday when we have another stream. Till then, you all take care of yourselves and each other, and let's go right into Nerduino. I'll see you there, everybody. Take care. Bye.